Python has surpassed French in primary schools. This one certainly seems strange. Unbelievably, Python overtook French in 2015 as the most widely used elementary school language. According to stats, 60% of parents would rather want their kids to learn Python than French. This shows that a large number of people understood the value of Python programming. The same stats show that 75% of elementary school students would choose to learn how to operate a robot over French. Are you guys ready to learn Python intermediate topics? Hello everyone and welcome to SimpliCode's YouTube channel. I hope you guys are doing well. Today, we'll be taking you through the Python intermediate full course. This Python full course will cover all the intermediate level topics of Python. In this video, you will see how and why Python is used. And by the end of this tutorial, you will be able to understand and deploy certain projects using Python. But before we begin, let me tell you guys that we have regular updates on multiple programming videos. So if you are a programmer and if you want to learn something new, then consider getting subscribed to our YouTube channel and press that bell icon to never miss any updates from SimpliCode. So let's go through the agenda for this full course tutorial. We'll start this video with an introduction to file handling in Python, followed by covering object-oriented programming concepts of Python. We'll move on and cover the most important topics of Python, which are inheritance, polymorphism, exceptions, functions, iterators, and modules in Python. We'll also cover Python packages in this tutorial. We'll end this video by going through certain Python projects, including creating games and password checkers. And finally, we'll create Flappy Birds using Python. All the concepts we are going to discuss in this tutorial are intermediate level topics. So if you are new to this channel, consider going through the previous Python course for beginners to understand today's topics better. I hope you guys are ready to learn something new. So without any further delay, let's get started.
Now, file handling is basically needed because most of the times when we're handling large and different types of data in Python or in general, we cannot store everything into a variable and we will have to use files. Now, there are two types of files that we are going to deal with. They are binary and text files. So binary files are some of the files that most of the files that we commonly encounter, like document files, image files, video files, etc. Now, all binary files are encoded in a particular format and they cannot be read by a normal text editor. And we would be needing certain specific softwares for specific files. Text files, on the other hand, do not have any specific encoding and they can be opened in the normal text editor itself. And they are like XML, CSS, HTML files, and so on. Now, there are four main operations that we can do in Python on files. They are open, read, write, and close. There are certain other operations as well, though, like rename, delete. So some of the most basic operation that we can do is obviously creating and opening a file. And the syntax is as you can see here, where we use the open command and we give a file name and we give a mode and we store that in a particular variable. Now a mode is basically telling Python how to handle this opening. So we can have a read-only mode which is done by this letter R, a write-only mode which is done by letter W, and there are a bunch of other modes such as read or write mode which is done by R+, and we are going to see them as we encounter them. Now, it's important to note that what I just mentioned is for text files. If we are going to do, for binary files, we're going to do this file handling, then we would be using the letter B in front of whatever we were using in the case of text files. So if we were doing a read-only mode for opening a binary file, we would be using RB. And if we were doing read and write mode, read or write only mode, for a binary file, we would be using RB+. So basically just adding the B in the case of binary files. Let's look at a basic example. When we want to open a particular file, we are going to open, like in this example, I'm going to open some file called filehandling.txt in a read and write mode, read or write mode, and I'm going to store it in FO. So this is as simple as it gets. Similarly, if I wanted to do it for a binary file, since I'm using a binary file, I will use the letter B as well in the mode. And that's how you do it here. Now let's look at different ways in which we can read from a file. And there are three commands that we can use. We can use the read command followed by an optional number of characters. We can use the read line command followed by an optional number of characters, and the read lines command. So this optional number of characters denoted by n over here, and basically it's telling us how many characters we want to print. So let's look at a simple example of where I'm going to print something called, so I'm going to take this and I'm going to do a print on top of this. So I have done first, I've opened it and I've stored it in my file, and then I'm going to do a method or a function called read, and I'm going to say, like in this example, just read the whole thing. So as you can see, my file that I have opened has all of these lines. This is like the whole file basically. But now what if I wanted to open only the first 5 characters of this file, which is basically this? Well, in that case, let's open this once again. Now let's do the same read command, except we will give the character number, which is 5. As you can see, it's only printed 5. Now let's do a print read command and try to read the whole thing again. And you will notice something very interesting. Now when I do the read command, you can see it's kind of picked up from where we left off from our previous command. And that is the nature of how Python handles files. So if I wanted to again take the cursor back in such an example, I will have to open this again, and then I use this read command once again to get back to where I started from, as you can see here. Now another command that we can use is the read line command. So let's once again open this over here, and now we're going to use the read line command over here. So what read line command is going to do is going to, each time we use this command, it's going to go one by one and read each particular line from this file. So in first case, it will take artificial intelligence, then data science, big data, and so on. So as you can see, if I execute this, it first takes artificial intelligence. Now if I did this command again, it will say data science. Next time if I do it, it should say big data, as you can see here. Okay. So this is the read line command. Now within the read line command also we can enter characters, and that will tell us basically that we want these number of characters from the next line. So if I want the first 6 characters of the next line, I will say 6, I will enter 6 here, and it will give me the first 6 characters of this particular line, which is the next line that is to come, as you can see here. Now another way in which we can print whatever is there in our file line by line is by using a for loop. So again, I'm going to open this file, I'm going to store it here. Now I'm going to use a for loop saying that, well, for line in my file. And what this does is basically at each iteration, it's going to take each line and store it in this variable that we enter over here, which is called line itself. And we're going to print that. At the end of the loop, what we'll have is all of the lines have been printed one by one. And another thing that we can do right now is, say we want to read a particular line. Say I wanted you to read the 5th line of my file. I can use this technique where I just say, okay, I'm going to store 5 in this variable called line number, and I have this another variable called current line, which I'm going to initialize with 1. And what I'm going to do is I'm going to do the same loop where I'm going to say for line in my line, but I'm going to add a condition saying that only if current line, when it's equal to line number, am I going to print the line, and then I'm going to break out of this whole thing. And at the end of each loop, I'm going to say current line is going to be incremented by 1 until basically these two variables are equal. So when I do this, I get my result, which is machine learning, which is the 5th line of whatever file I had. Now we're going to move on to the topic of image file handling. So we saw how we handled and we saw certain operations around text files. And text files are obviously something that we're going to use a lot. But we are also going to be using files such as images a lot. And let's look at certain examples and certain use cases around image file handling. So my first step is going to be importing a bunch of modules and packages. Now the details of these modules and these packages are not important as of right now because they will be covered in a future video. But just keep a note of some of these packages such as let's say NumPy and the image package. So once I've done this, let's move on to my example. So what I'm going to do is I'm going to store certain file locations in 2 variables. So it's basically 2 strings. I've attached the this prefix R to say that this is a read-only sort of a prefix. So the next topic that we're going to be handling is image file handling. Now we have already seen many examples pertaining to text files. So text files are obviously something that we're going to be using a lot. But image file handling is something very important as well. And we're going to see certain operations that we can do around image file handling. So starting off, I'm going to import a bunch of packages and modules. What these packages exactly are and what these modules exactly are right now not that important to you right now, but it's something that will be covered in a future videos. It's important to just keep note of what these are, such as NumPy and image. So once I've done that, what I'm going to store is I'm going to store two particular file locations in two variables, location 1 and location 2, and I've prefixed them with R just to say that these are raw strings. So once I've done that, I'm going to use the image from the image package. I'm going to say open, and I'm going to say open from this particular location and this particular location, and I'm going to store these images in IM1 and IM2 over here, very similar to a normal text file opening. Now once we've done this, we can access certain properties of this image using, say, format, which tells us the format of the file. It identifies the source of an image, and if the image is not read from a file, it is set to none. We can also see the size of the file using the size attribute, and we can see the mode, which basically defines the number and names of the bands in the image, and also contains the pixel type and depth. Certain common modes are like L for luminescence, RGB for true color images, and CMYK for pre-press images. So let's look at them. So when I access this, you can see my first file is of JPEG of this size and an RGB format image, and my second image is another JPEG, slightly bigger image, and again RGB. Now we can also, of course, display these images, and to do that we can use the PLT. Again, PLT is supposed to stand for matplotlib.pyplot. It's a particular package that, again, you don't need to know the details of right now, but this is how we would do this. So I'm going to use a bunch of commands and methods such as figure and subplot and then IMShow. So once I have done this, as you can see, both of my images, with this being IM1, this being IM2, have been produced on the screen, as you can see. I can also use display, this display function followed by the name of the file, and this will simply display my image, as you can see here. Now I can obviously save a particular image using the save function, which is as simple as just doing this. So I'm going to save the image as im_save.jpg over here. Now if I wanted to crop an image, I can do that as well. So I stored the dimensions that I want cropped in the form of a tuple, as you can see here, and I'm going to pass that tuple to the crop function, and I'm going to apply that on top of IM1, and I'm going to store that to region. Once I've done that, as you can see, so basically what I've done is I've cropped this image based on whatever I've passed here, and I've stored it into region. And now if I wanted to see what was actually in that crop, I can just do the IMShow function, and I'm going to pass the particular cropped image, which is denoted by region, as you can see here. And you can see my cropped image is basically a left portion of this whole image has been cropped out, and I have produced it over here. Now I can also use the copy function. It's a simple basically copy. You use the copy function, and it copies an image onto another variable that you have assigned. And when I use the IMShow function, I'm going to show you the copied image, which is basically the same. Now we can do the transpose operation as well. So let's see let's see what we have done here. So in this transpose operation, so in this basically I've done a bunch of operations such as rotating by 90 degrees, rotating by 180, rotating by 270. And finally, once I've done with all of these multiple operations, I'm going to show you the final output, which is basically a certain transposed image like this, which is basically the result of whatever I have done before this. So this is it for this video on file handling. I have shown you two slightly more comprehensive examples on text files and even certain examples on image files. However, we can use file handling in different libraries pertaining to file handling for audio files and even for stuff like PDF files. And this is just only the beginning, and I'm sure you will encounter a lot of different use cases, different examples as you continue learning Python programming. Well, as the name suggests, object-oriented programming is all about creating objects. An object is a group of interrelated variables and functions. Variables can be referred to as the properties of the object, whereas the functions can be referred to as the behavior of an object. So if we were to treat, say, for example, a car as an object, its properties would be its color, its model, its price, and its brand. whereas its behavior or functions for that matter would be like accelerating, gear change, braking. Similarly, if I give you an example of a dog as an object, we could consider the properties of the dog as its weight or its name, its breed, its color, whereas its functions could be, say, barking, playing, eating, walking, etc. Objects provide a better and a clear structure for a program. Now let's move on to what is a class and an instance. Now a class is like a blueprint or a template of certain functions and entities, whereas an instance is a particular realization of a class. Classes are used to create user-defined data structures and define certain functions called methods within the class, whereas instances are realizations of these classes. And when we are speaking of classes and instances, classes don't contain any real data. They are just merely templates. Instances, on the other hand, contain real data. To think of an example of the difference between a class and an instance, think of a class like a empty form or a questionnaire. Now, an empty form or a questionnaire does not have any information, but it does have a template to it. It tells you to fill in certain information, and based on who is filling in the information, that information or the data on a particular form will be different. So an instance is like a filled out form with its own unique set of information. That is one way of treating or understanding what is a class and an instance. Now for our first example on classes, I will be taking you through a class where I've defined based on the circle object. So this class is going to define basically information about your general circle, such as its radius and its area. So let's go through it. Now obviously, to define a class we need a keyword. Well, in the case of classes, we use the class keyword followed by a name for that class. So in this case, my name is circle. Now, after the colon, every information that is part of the class has to be obviously indented, as is typical for Python. Now you can see over here a bunch of def keywords followed by something that you might not be familiar with, and I will try to get you through this. So if you see here, you have a def keyword followed by init, and this init is prefixed by a double underscore and it's suffixed by a double underscore. And you can see the same thing for str and repr. Well, this double underscore is called a dunder, and any method, these are of course methods. This is a method, this is a method, this is a method, this is a method. Now any method that is prefixed and suffixed by double underscores are called dunder methods. These dunder methods are or can be thought of like predefined or built-in methods for any class that you define. So these we have like 3 dunder methods over here, and we have one user-defined method that we will get to. So this first method that you see here is the init method or the initialization method, and this is invoked or called whenever we create an instance of this class circle. And what we do here is basically we pass when we create this instance circle, what happens is that we get an option to pass a value for what is this keyword or variable radius. So if I pass, so you will see me later on creating an instance where I will be passing a value, and that value is basically stored as the radius. And by default, the radius that will be passed whenever we create an instance for this class is 1. The str method is basically used to return a descriptive string for the instance of class. REPR is not something that you have to bother with right now. And now get area is something that you should follow, because if you see here, I have not used any double underscores. So this is a user-defined method. User-defined methods are so methods that we define, and these are like tasks that we define on our own. So in my user-defined method called getArea, I will be returning the area of this circle based on the radius that I pass to it. Now if you notice here, before in every method, I have this self keyword before any other attribute. So like this has self, even the getArea has self. Now what this means, self is like an optional keyword that is used to improve readability of a program, first of all. And it's also the function of the self keyword is basically telling Python that any of the methods that we are invoking in this class or the instance of this class has to refer to attributes and variables within that instance of that class. So if I'm going to use getArea function, I'm going to get values and attribute values and variable values based on only the current instance of that particular class. Self is obviously optional. We don't really need it, but basically the first attribute of any method is basically the instance that the method is invoked upon. So if I say self, I'm telling this particular function that, okay, all the value that you're going to get for performing whatever task you want is going to be found in that particular instance where you have been invoked itself. Now, don't worry if all this is very confusing. This might be in the beginning, but just try to understand that this is something that we do for good practice, and you will understand when to use self or when not to use self as you learn about object-oriented programming. So if you see here, my getArea function is supposed to return the value radius times radius. Self.radius is basically telling whatever value I've passed for radius for that particular instance. You can read this as radius times pi as well. So obviously this is pi r squared, which is the area of a particular circle. Now let me show you an example where I'm going to perform some of these functions. So if you see this first line, I have created an instance of the class circle where I've passed 2.1 for the radius of the circle. So now the value of the variable radius in this particular instance is going to be stored as 2.1, and this particular instance is going to be stored in the variable c1. Now the print c1 function invokes the str self-defined or predefined function. Now if you remember, it's basically used to return a particular string that describes like what the class will do, and this is something that we define on our own. In our example, str will return the string saying this is a circle with radius of, and then it will return the radius that we passed. So in this case, it should say this is the circle of radius 2.1, as you can see over here. So if I execute this, you can notice this line. This is a circle with radius 2.1, and this is invoked by the print function. The print basically invokes the Dunder str function, which does all of this. Now in the next line, we say print c1.getArea. So this is going to print the value of what gets returned when we invoke the method getArea for this particular instance c1. So obviously in this particular instance, our radius is 2.1. So the getArea function should do pi times 2.1 squared. And the value is, as you can see here, is some 13.85. So that is the area that we got. Now if we want to print a particular radius, we just say print c1.radius. So this will print the value of what is stored in radius for the particular instance c1. Now you might notice me using a dot whenever it comes to defining a certain function or a keyword. Well, any time that we want to invoke or use a method of a particular class, we have to use the dot keyword. So we use the instance name c1 dot followed by whatever method that we want to use. So if we want to use the getArea function, we say c1.getArea. If we want to find out what is there in the radius radius variable of a particular instance, we say c1.radius. Now before we move on, let's talk about some of the naming conventions. Class names are initial capitalized. So if our class name is, for example, if it's camel case, well, each word that is part of this class has its first letter capitalized. Variables and method names are in lower class. So if my class was called circle, we say class circle with C being in capital. Now moving on, let's talk about how we initialize or define instance variables. Now instance variables are declared within the init method. If you remember from the earlier example of circle, init is a Dunder method. It's followed and it's preceded by double underscore, as you can see here. Now if you see in this particular case, I have again used the self keyword, and as I mentioned earlier, the self keyword is the first parameter of all member methods, and this basically binds that particular method to the particular instance itself during invocation. So every time a new circle object is created, the .init function sets the initial state of the object by assigning the values of the object's properties. So the init function basically initializes each and every new instance of of our class. So we can give init any number of parameters, but the first parameter must always be a variable called self. Now when a new class instance is created, the instance is automatically passed to the self parameter in init so that new attributes can be defined on the object. Inside the init method, the self.radius basically means that we want the value of radius based on the current instance itself. So as you can see, radius defines an instance variable radius, and we're going to use the particular instance and its value for radius in our variable radius. Now, instance, the init function is not a constructor, but it is an initializer to create instance variables. The init function also will never return a value, and it is optional and can be omitted if there are no instance variables. Now, let's move on to class variables. So now, as we mentioned earlier, all the attributes that are created inside the init function are instance-specific attributes. And the instance attributes are obviously specific to a particular instance of the class. For example, all dog objects. Now, if we have a class called dog, then all dog objects have a name and age, but the values for the name and age will vary depending on which dog we are talking about, or basically which instance of the dog are we talking about. Now, class attributes are attributes that have the same value for all class instances. And we define a class attribute by assigning a value to a variable outside of the init function. So if you look at this example over here, we have created another class called circle, and we have this initializer again, where we have a class specific variable called radius, whose value will change depending on whatever we pass for that particular instance. However, if you look before the init function or the initializer function, if you see here, we have another variable called shape object, which stores the string circle. And this variable is going to be the same and constant for every instance of the class circle. And unlike the variable radius, we will not have different values depending on a particular instance. Okay, now let's talk about instantiating an object, and let's see what happens when we create two different instances of the same class. So as you can see here, I've created an instance C1 for class circle, and I'm going to check its ID. Well, if you see, the ID is something like this. Now, if I created another instance over here called C2, and if I check its ID, well, it's something different now. So if you see, each instance basically has a different memory location in our memory, and this is how each instance is different each time we create it, and they are created in different memory locations. Finally, before we conclude this topic on the introduction into OOP, let's talk about class methods, instance methods, and static methods. Now, class methods are actually declared with the @class method operator or decorator, as you can see here. It accepts the class as its first argument. So in this case, I'm going to define a class called myClass. I'm going to use this @class method decorator to say that whatever follows here is going to be a class method. And I've defined a class method called hello that takes in that uses again self and a name attribute. So what this does is it prints whatever I have passed to it in the form of hello from self.name. Now what this is going to do is basically it's going to give out a string saying hello from name of the whatever class we have and whatever we pass in the attribute name. So in this case, I'm going to invoke this method using the class name itself. I'm not going to use an instance name because I have no instance in this particular example. And since this is a class method, it can be invoked using the class name itself. So I'm going to pass Rakesh, and let's see what happens when we do this. As you can see, the first print will basically give us the information of the class itself. It's saying that the class is called myClass, and the second print statement is basically a string saying hello from the string name myClass with a comma and then whatever we passed initially, which was Rakesh. Next is then instance methods, and these are the most common types of methods. These are invoked by an instance object. So we have to create an instance to actually use an instance method, and it takes the instance or the keyword self as its first argument. So if I say if I define a class myClass in this example, and I'm going to define another function called hello. As you can see, I have not used any decorator like @class method. So this is going to be an instance method, and it's going to be invoked by the particular instance. So in this case, it's going to print hello from, and it's going to basically say the name of the class again. So I create my instance called myInstance1, and it's an instance of this class. And then I'm going to invoke the instance method by using this dot operator and the instance name. And the result will be basically this string over here, as you can see. Now finally, we have another type of method called the static method, which is declared using the @static method decorator. So a static method does not know its class and is just attached to the class for convenience. It does not depend on the state of the object and could be from a separate function of a module. a static method can be invoked via a class object or an instance object. So if you look at this example over here, I have defined a static method. I've defined hello, and it basically says print hello world. So it's going to basically just print this. So if you can see here, I've created my instance and I'm going to say dot hello. It should basically print hello world. That's all. So guys, this was it for the introduction on OOP. In our next video, we will be covering the next topics of OOP, and we will be starting with inheritance in our next video. Inheritance is used to describe the relationship between two classes, wherein one class takes the methods and properties from another class. In this relationship, we have something called the base class or the parent class, from which we will derive all or some of the properties and methods, and the class which actually derives these properties and methods is known as the derived class. So you can think of the derived class as a specialized version of a base class. To explain what inheritance is in a basic way, I will show you an example where I'm creating a cylinder class, which is going to be a subclass of the circle class that you might have encountered in the earlier video on OOP. So what we're going to do is create a cylinder class that is a subclass of circle, where we're going to get the attributes radius and get area from circle class, and we're going to add the attributes height and get volume to the cylinder. So right off the start, you can see we have our class circle that you might have seen in the earlier video. So this class circle has the familiar initialization, where we are supposed to enter a value for a radius that gets stored in self.radius. Now we also have a description string, which basically is a Dunder method that returns a string when we invoke the print command on a particular instance. And we have the getArea method as well. Now if we move on to the cylinder class, you can see that I'm defining this class with the class keyword with the cylinder name, but you can see that I have added a parenthesis, and within it I have mentioned the name of the superclass that I want the cylinder class to be a subclass of. So this is how we actually define a subclass in the most basic way. You enter the name that you want, and you enter the name of the superclass that you want the subclass to be a subclass of in parentheses right after the name. Now next, if you move on to the Dunder Initialization, the initialization is very familiar, except now we have another attribute for height, which has a default value of 1, just like the radius. So this basically means that we have an option of entering two different attributes for our cylinder instances. Now if you see here, there's a line which says super.init. Now this is like, this is a command which we use to invoke the superclass's initializer. So anytime we create an instance for cylinder, we also want an initialization for the circle method as well as a part of our cylinder instance. Next, you can see that much like how we stored the radius attribute in self.radius, we're also storing the height attribute in self.height. Now even this cylinder class has an str method to return a particular string if we use the print function. And finally we get on to a new method that we have defined only for the cylinder class called getVolume. Now if you see the getVolume, it returns us basically the volume of the cylinder that is being described in the particular instance, for which we enter the height and the radius. So if you can see here, what we basically added extra is a height attribute and another method called getVolume. And the other parts of the circle superclass, such as radius and getArea, are also going to be a part of cylinder, even though you do not explicitly see them anywhere here. And we will see how in the form of an example that's coming up. So let me just execute these classes. Now that that's done, I'm going to create an instance for cylinder. I'm going to store it in cy1, and I'm going to pass 1.1 for the radius and 2.2 for the height. And once that is done, let's just print to invoke the str method. And as you can see, the str method basically tells us the information that it's a cylinder with radius 1.1 and height 2.2. So now let's print what is the value we get when we use the getArea method. Now it's important to note getArea was not explicitly defined in the cylinder subclass, but it's a method that is a part of the circle superclass. And we can see that we can actually access methods that are part of the superclass simply by accessing any other method. So if we use the .getArea, you can see that we get a value for the area of the cylinder. So this area is basically the area of the circle face of the cylinder, the top or the bottom. Now let's invoke the subclass specific method, which is the getVolume method, in a similar manner. As you can see, just by invoking this method, we get the volume as well. Now, if we want to see what is the radius and the height, we can just do a simple print statement followed by cy1.radius, cy1.height, and it gives us both of these values, as you can see here. Now over here, what I'm going to do is create another instance of cylinder, but I'm not going to pass anything for radius or height. So basically, it's going to take the default values for radius and height, which was 1 and 1 respectively. So once I print, this statement is basically going to print the str method or whatever we stored in the str, which is basically the description of the object followed by what is its radius and height. This method will give us the area and this method will give us the volume. So once I execute this, as you can see here, this is what we get, and this is what we expect as well. So now in this example, what I'm going to show you is now I'm going to go back and I am going to create another instance for circle. Now this is the superclass, of course, and I'm going to give it, and since the superclass has only one option, one attribute that we can enter, which is for the radius, so I pass 3.3. And I'm going to print what happens when I just print this instance. It's going to basically give us whatever was a part of the str method. After that, I'm going to print isInstance. This is basically a check on whether C1 is an instance of this class circle, and next I'm going to check if C1 is an instance of its subclass cylinder. Now when I execute this, you can see that well, this is what we this is the str method that gets printed. But if you see here, you can see that it says C1 is indeed an instance of circle when it says true over here. But when we look at the next line, is C1 an instance of cylinder? It says false, and this is obviously because a superclass object is never an instance of a subclass object, whereas vice versa it would be true. Now in the next part of this video, what we're going to do is look at the different types of inheritances in Python. So there are basically 5 types of inheritance in Python. There is the single inheritance, there's multiple inheritance, multi-level inheritance, hierarchical, and hybrid inheritance. So we will go one by one and see each of these examples. Starting off, we have the single inheritance. This is simply where we have one base class and one derived class from that base class. So this is just simple single inheritance. And in this example, you can see I have a class called country where I have a method that I have defined called show country, which is basically going to say print this is India. It's basically going to go print this every time we invoke this show country method. Then we have a class called state, which derives from the superclass called country, where we have a method called show state, which is going to say print this is state every time. So you can see I created an instance of the class state, and through that instance I can access the superclass and the subclass methods over here. Next we have the multiple inheritance, and this is when a derived class contains more than one base class. So let's look at an example to understand this. So if you can see here, I have a class called student with 2 methods defined called method 1 and method 2. In method 1, we can pass 2 attributes, SN, SNO, or I think this is supposed to be like an ID, I guess, like SN number, and we have S name. So this is basically 2 attributes we can pass that are probably descriptors for a student. And in the next method, you have basically 2 print statements which says student number, and then they will print the student number, and it will also print the student name. Next we have a class called marks. This is also so these 2 classes are basically what our super classes are going to be, and we're going to derive a third class from these 2. So this second class is a class called marks, and we have 2 methods again. One method is called setMarks, which has the option of putting in 2 attributes, m1 and m2, both representative of the 2 marks, and we store them in self.mark1, self.mark2. The second method is putMarks, which is going to print the marks, namely mark 1, and then it's going to tell us how much marks are there in the first subject, for example, and another print statement doing the same thing for the second subject, or mark 2. Finally, we have a third class called result, which derives from 2 classes, marks and student, as you can see here. In my parentheses, I've passed in marks and student. Both are super classes, and our class result is going to derive from both of them. This is an example of multiple inheritance. And within this class result, I have 2 methods specific to this derived class called calc, wherein I'm going to basically calculate the total marks of the total marks, which is basically the addition of mark 1 plus mark 2, and then I'm going to have another method called put total, which is going to print me what is the total. So if you can see here, I have created an instance of this derived class called result. I'm storing it in R. Then I'm going to access method 1, which is obviously a method from the first superclass called student, and I'm going to store, okay, so this is name is, I guess, Lucky, and he has 60 marks. Secondly, then I'm going to do our set marks, which is the method from the second superclass, which is going to set the marks respectively. So you have Lucky student, and his ID is 60, and he has got 50 and 60 marks respectively in, say, the first two subjects. And finally, I'm going to access the derived class method called calc. So this is going to do the sum. Finally, I'm going to also do our method 2, which is going to print our student number and his student name. Next, we're going to have put marks, which is going to tell us the what are the individual marks for mark 1 and mark 2. And then finally, we're going to print the total marks with put total. So once I execute this, you can see here it says student number 60, student name Lucky, marks 1 is 50 as I had written here, marks 2 is 60 as I passed here, and then total is 110, which is basically 50 plus 60. Our next type of inheritance is called multi-level inheritance. Now, multi-level inheritance can be assumed as where you take a superclass, let's call it A, and you derive a class B from that class A. Now, what if we derived a class C from B, and we kept doing this? So until, say, a class E. Now each of these steps is in its own an inheritance, but this whole relationship can be described as a multi-level inheritance. So let's take an example again. So this time I've defined a class called student, where I have defined two methods called set stud and put stud, or you can call it set student and put student. In my first method, I have two options of adding two attributes. Again, this is the student number, this is the student name. In my second method, I am going to print what is the student number and what is the student name. Finally, next we have another class called marks, which derives from the first class called student. This has two methods called set marks, where I'm going to again get the option of adding two integers for m1 and m2, which is going to represent mark 1 and mark 2. And finally, I have put marks, the method which is going to print mark 1 and mark 2. Finally, I have another class called result, and this, if you see, this derives from marks. Now, if you see this relationship, you'll notice result derives from marks, whereas marks itself derives from student. And this is an example of multi-level hierarchy. And even as a part of this third class, we have its own methods called calc and put total. Calc will calculate the total as we had seen earlier, and put total will basically print that total. And we're going to do a very similar operation. We're going to create an instance of this third class result and store it in R. Then we're going to do we're going to set the student details, his student number and his name. We're going to give him his marks 50 and 60. We're going to calculate what are the total. We're going to say, okay, now put the details of what is the student's number and name. We're going to also display his marks, mark 1 and mark 2, and finally we're going to display the total marks. So let's execute this. And if you see, it's basically the similar operation that we did earlier, but the only difference is in the earlier example, our third class result was derived from marks and student together. So this was an example of multiple inheritance, whereas in this example, the result class derives from marks and marks itself derives from student. So this is an example of multi-level inheritance. Finally, we have, penultimately we have as our fourth example of inheritance called hierarchical inheritance. Pardon my mispronunciation, it's hierarchical inheritance. So in this case, a base class basically will contain more than one derived class. So let's look at an example of what we mean here. So I have a class called 1, where I have defined a method called display, where what I'm going to do is I'm going to store self.x is equal to 1000 and self.y is equal to 2000. Then what I'm going to do is I'm going to print a statement saying this is the method in class 1. And I'm going to say, after that I'm going to print another statement saying value of x is self.x, which is going to be 1000. Then I'm going to have another print statement saying value of y is self.y, which is going to be 2000. Finally, next I have another class called 2. This is going to derive from class 1, as you can see here. And in this class 2, I have defined another method called add. And in this method add, what I'm going to do is I'm going to first print a statement saying this is the method in class 2. And then I'm going to actually print the result of x plus y, which is 1000 plus 2000. Finally, I have another class called 3. And this is also deriving from 1. So if you notice, we have one parent class called 1. And from this one parent class, we're going to derive two different subclasses called 2 and 3. So this is an example of hierarchical inheritance. Now in this class 3, what I've done is I've defined a multiplication method. What I'm going to do is print, first of all, I'm going to print this when I invoke this method, that this is the method in class 3. Finally, I'm going to say, I'm going to print the result of x times y, which is 1000 times 2000. So if you see, I am going to create an instance of 2 and I'm going to create an instance of 3, and I'm going to store them in T1 and T2. Now since T1 is an instance of 2, so I can access its methods add and I can access its methods display. So I'm going to use T1.display, and even in T2 I mean, since it's a class, it's an instance of class 3 and this also derives from class 1, I can also access its method display, but now I cannot access add, but I can access multiply. So if you see here, I access add through T1 instance, since add is a part of class 2, whereas multiply is a method in class 3. So I access it in its respective instance, which is T2. So if you see here, now once I execute this, what you will get is basically the results. So first of all, it will basically display the method from class 1, which is a display method. It will display the values of x and y. And since I've done this twice from 2 different instances, it will basically show a repetition over here. Finally, I've done the addition, and since this is a method in class 2, it is going to say as much. That this is a method in class 2, and then it's going to say x plus y is 3000. And now multiply is a method in the third class, so it's going to say this is a method in class 3, and it's going to tell me what is the multiplication result. Finally, we have what is called hybrid inheritance, and this is a combination of multiple plus multi-level inheritance that you saw earlier. So let's again understand this through this example. So we have a class called student, where we have a method called set student. Again, 2 attributes we can pass here for student number and student name. Next, we have another method, part of the class student, called put student. So this will print us the student number and student name. Next, we have a class called marks, and this marks inherits from student. So we have a method in class marks called set marks, where we can pass 2 attributes for mark 1 and mark 2 respectively. And as we had seen earlier, we also have a put marks, which will display the marks for marks 1 and marks 2. We have a class called practical. This practical is basically another superclass. If you see here, since this does not derive from anything, it is a superclass on its own. And what it does is it has 2 methods, get practical, and we can pass an attribute for p1 here, and we store that in self.p1. And then we have an attribute for put practical, which will print us the practical marks, whatever we passed for this attribute in p1. Finally, if you see, we have a class called result. Now in this result, we are going to derive from marks and practical. But if you notice here, marks itself is a subclass of student. So this is an example of multi-level inheritance. Whereas since result derives from marks and practical both, it is also an example of multiple inheritance. So if you see, notice here, this is an example of multiple and multiple level inheritance, which is basically what we call hybrid inheritance. And as we had seen earlier, this result class will have a calc method to do a total of the marks. In this case, mark 1 plus mark 2 plus the practical mark p1. And we have a put total method, which is basically going to print us the total. So now we're going to create an instance of this result. And through this instance of result, we're going to first invoke the parent class method called set student, which is the second level parent, basically the student class set student method. So we're going to set student here. We're going to say 60 is the student ID and name is Ash. Then we have set marks, which is again the second level parent, which is a student class, where we set the marks. Finally, we access this get practical. Now, if you notice, get practical is part of the practical superclass. So in this, we store the third subject, or the practical marks 100. Then we calculate the total, and we put first the student details, then we put the individual marks, then we put the practical marks, and finally we enter what is the total. So let's execute this. And if you notice, you will see here student number is 60, student name, and all the basically whatever details we wanted is shown over here. So this was it, guys, for our video on inheritance. Again, we will continue with our topic of object-oriented programming with the topic of polymorphism in the next video. Now, the term polymorphism in OOP refers to the ability of an object to adapt the code to the type of data it is processing. Polymorphism is one of the key concepts of Python, and it is also a built-in feature of Python. An example to get us started on polymorphism would be how we use the plus operator. We use the plus operator not only for arithmetic additions, but we also use the plus operator for stuff like string concatenations or joining two lists together. This example where we're able to use the plus operator for different operations is an example of polymorphism. To show you what I mean, I have basically done a simple addition operation here, where I'm adding two variables, number 1 and number 2. When I do it on integers, it basically adds 1 plus 2. Now when I use it on two strings, str1 and str2, which contains Python and programming, two separate strings, and when I use the plus operator on these, you can see what it does here. It forms one string containing both of these individual strings. So this is basically the plus operator showing polymorphism, and is one of the simplest occurrences and yet most common occurrences of polymorphism in Python. Another example of polymorphism would be through the length function. The length function in Python is something that we use a lot and over multiple data types. Depending on the data type that we use the length function for, we get a different value or a different sort of information from the length function. Now if you see here from this diagram, when we use the length function on a string, it gives us the length of the string. When we use the length function on a list, it gives us the number of items. Whereas if we use the length function on a dictionary, it gives us the number of keys. So this is, well, another example of how we have polymorphism in a function. Now what we're going to do is look at the different techniques through which we can enable polymorphisms in our code. Our first example that we are going to look at is through method overloading. Now method overloading in its traditional sense, where we can have a method with the same name, more than one method with the same name in the same class, is not exactly possible in Python. So if we have multiple methods with the same name in a class in Python, which may differ in types and number of arguments, are not allowed and not supported in Python. In fact, if we did something like this, where we created a method with different say types and number and arguments, but having the same name in the same class, then what Python will do is it will only recognize the last defined method, and it will not recognize any of the earlier methods with the same name. But we can simulate polymorphism through method overloading by using default arguments in a method. Now for example, what I'm going to show you here is an example where I have a method called sum. Now by default, it has three attributes that you can pass through this method. A does not have a default value, B does not have a default value, but if you notice, C has a default value 0. So this is a simple example where I'm going to show you that the sum method is going to be used in two different cases. In one case, we're going to simply add two numbers, and in another case, we're going to use the sum method to add three different numbers. So we have this class overload demo, within it a method sum, and I have three attributes. A and B are supposed to be given by the user since they do not have any default values, whereas C has a default value 0. So if you see here in my first case, I first of all created an instance called OD for the class overload demo, and what I'm going to do is I'm going to store the value of the sum of 7 and 8 in the variable sum. Now if you see here, I have not passed a third argument. So what this method is going to do is it's going to take the value of C as 0 by default. So it's basically going to do 7 plus 8, and it's going to give us the sum for 7 plus 8. And in the next instance, I'm going to give three arguments, 7, 8 and 9. So now C will be replaced by 9 instead of 0, and then I'm going to get the sum of 7, 8 and 9. So in this is not a very commonly used thing, but it's basically a method just to show you that we can actually simulate method overloading in Python by using default arguments. So I've basically shown you how the same method sum has been used to do the addition of 2 digits, and then in another instance is doing the addition of 3 digits. It might look very similar, but you'll basically notice that by having this third attribute C have a default value of 0, I have induced some form of polymorphism through method overloading. Now the next way that we can induce polymorphism is through inheritance, which is called method overriding as well. Now method overriding gives us the ability to change the way or change the implementation of a method in a child class which is defined already in one of its superclasses. Now if there is a method in a superclass, the method having the same name and same number of arguments in a child class, then the child class method is going to override the method in the parent class. So what we do is when a method is called with the parent class object, the method of the parent class will be executed. Whereas if we call the method using the child class object, the method of the child class will be executed and it will override the method in the parent class. So the appropriate overridden method is called based on the object type, which is an example of polymorphism. So let's look at an example to understand this. So we have a class called person, and we have defined what we're going to define the initializer is two attributes which we have to pass called name and age, and we're going to store them in self.name and self.age. Now we have a user defined method called display data, where we're going to print if this display data has been called through the parent called person. If it's going to be called through the parent class object, then we're going to print in parent class display method, and then we're going to print the name and age that we have entered. Now we have another class called employee, which is going to be a derived class on person. So it's going to so it's also going to have an initializer, and this constructor will basically what this initializer will have is it'll have an constructor for the superclass, where we're going to do this the same initialization that we do in the superclass, but we're also going to store another attribute called ID in self.employeeID. And if you see here, we also have another method called display data, which is the same named method from person. But now if you see in display data, I have almost the same information. I'm going to print the name, I'm going to print the age. But if you see the first statement, I'm going to say, if I'm going to call this method from the employee object, then I'm going to say in child class display data method instead of in parent class display data method, to say that basically I'm invoking this method from the child class object. And I'm also going to print on top of the whatever I'm printing before, I'm also going to print the employee ID. So if you see here, I have created an object called person, which is an object of the class person with the information of name John and age 40. And then I'm going to display this. Now next I'm going to create an object called emp, which is the child class employee object, which is going to now have the same information of John for the name and age 40, but now it's going to have an employee ID. And then I'm going to store this in emp, and I'm going to display the data for this child class object, and we will see the difference in how the display data is differing from the earlier case. So when I execute this, you see in the first case it says in parent class display data method. So this display data has been called through the parent class object, and I'm only going to show the information of name and age. Whereas when I invoke this method from the employee class object, it's going to say it's going to specifically say that it's a in child class display method, and then I'm going to say the name, age, and also the employee ID over here. So this is the difference between how display data has been used in its parent and its child class, and this is basically the example of method overriding. Now our next example of polymorphism is going to be through operator overloading. And operator overloading is the ability to overload the operator to provide extra functionality in addition to its real or core operation. And operator overloading is also an example of polymorphism, as the same operator can perform different actions. The earlier example of where we use the plus operator for different operations is an example of operator overloading polymorphism. Now when is operator overloading required? Well, anytime you want an operator to perform a different function for you in your custom objects, you would basically do operator overloading. Now an example of this would be what I'm going to show you below. So if you see this class called point, it has an initializer where I'm going to store two attributes x and y in self.x and y, and in self.x and self.y. Now I'm going to create one object called p1 where I'm going to create point 1 and 2. So you can think of this object as basically like a coordinate, x coordinate 1, y coordinate 2. This is one point, and another point called x coordinate 3, x coordinate 4. I'm going to call that p2. Now I want to print p1 plus p2. Alright. Now if I try to execute this, you will notice an error. It says unsupported operand types for plus, point and point. This basically means that plus does not know what to do when it's given an object of this type. It has no idea what to do. Whereas what we want it to do is add the x coordinate from this point and the x coordinate from this point. So we want it to do 1 plus 3, and we also want it to do this y coordinate plus this y coordinate, or 2 plus 4. And then we want to print basically like something like 4, 6, or the addition of the 2 points, or the vector addition of these 2 points. So this is what we want this plus operator to do, but the Python does not have any inbuilt feature for the plus operator, and we are going to have to basically do some operator overloading to create a polymorphism on this. So let's see how we can do that. So to do that, first of all, we have to understand that all operators in Python have internally defined methods to provide functionality for these operators. The operator or the special method to provide functionality for the plus operator in Python is the add method. And whenever the plus operator is used, we are basically internally invoking the add method. So these sort of internal methods that provide functionality for the operators are part of a bigger class of methods known as magic methods. And these magic methods are automatically invoked whenever its corresponding operators are used. So if we want to change the operation for the plus operator in this example, we are going to have to use the add method in this case. And since it's a magic method, magic methods are also are basically what we saw earlier in the form of Dunder methods. So magic methods are going to be invoked using double underscore, a prefix and suffix to it. So similarly to how we defined an init method or an str method, we are going to also invoke the add method using the same double underscore before and after its name. So now let's see how we're going to do this. So if you see this class, I have now my class point and I have the same initializer when I'm going to store x and y. Now I am going to define on this add magic method, I am going to override the normal functionality of plus, and I'm going to give it a very specific function where I'm going to say for two different objects, you're going to add its the first part or its so-called x coordinate with the other x coordinate and the y coordinate with the other y coordinate, and you need to return this to me in the form of a similar object. So now when I pass 1 and 2 and 3 and 4, it should return me 4 and 6. As you can see here, I have basically done what I wanted to do by operator overloading. I have changed, or I have overloaded this plus operator using this add magic method, and I have created a new functionality for this add function for these 2 points 1 and 2, 3 and 4. Now I'm able to add 1, 2, 3, 4 in the way I wanted to. So now that you saw how we did operator overloading, I'm just going to show you a list of similar magic methods for different operators that we are familiar with. So the plus operator already we've seen has the add method. Then we have the minus operator with the sub method. And similarly, we have for all of these operations such as multiplication, division, we have its respective magic methods. These magic methods are again prefixed with 2 underscores and suffix with 2 underscores, and they are also called dunders in Python. So this is how we would do operator overloading in Python for whatever operator we want. Similarly, we can do this for like comparison operators and for unary operators as well. So look at this example now where I'm going to overload the multiplication or the asterisk operator. So I've again defined a class called point, and I'm going to define an initializer where I'm going to store some attribute x in self.x. Now what I'm going to do is I'm going to overload the multiplication operator where I'm going to basically allow the this asterisk operator to multiply two objects from, like, for example 12 and 5. Usually I can just do a normal 12 times 5, but in this case my object is slightly different. My 12 is being passed through an object of a class called point, and 5 as well in another instance of the same class. Now when I want to multiply these class instances, like the multiplication operator does not perceive these class instances to be integers. So by default, it would not be able to multiply what we want to multiply. But when we define or we overload the multiplication operator within our class, it's now able to understand what to do using the attributes of these classes in its respective class instances. So it's able to say, okay, so I want this attribute from this particular instance p1, 12, and I'm going to multiply it with the attribute 5 from instance p2 whenever I say p1 times p2 or p1 asterisk p2. So when I execute it, it will give me 12 times 5. Similarly, I can also do this for the greater than operator over here. So I have a class called person where I'm going to define an initializer where I'm going to pass name and salary and store them in self.name, self.salary. The GT method is basically the greater than method, magic method, and it's going to we're going to use this to overload the greater than operator. And now again, using this greater than operator, I'm able to basically say object 1 greater than object 2, and I'm basically able to check through this, and if object 1 is greater than object 2, it will basically tell us if it is true or false, or basically whatever like we want to know. So basically the print statement will check for object 1.name, and it will say earns more than object 2.name if in case object 1 is indeed greater than object 2. So when I execute this, you can see here, my first information says John is earning 4,500 of some units, Natasha is earning 6,000 of some units. So it will say John earns more than Natasha. Well, it's false because object 1 is not greater than object 2. So since 4,500 is not actually greater than 6,000. And this is the check that I'm doing by overloading the GT operator over here, where I'm returning the Boolean value of what is greater, self.salary or other.salary. Self being the first object in any comparison. So if I'm basically any comparison, if I'm doing 5 greater than 6. So what the GT will do is this will be the self object and this will be the other object. So this is what I'm doing over here. I'm checking self.salary with other.salary in the form of these objects. And it's basically the same way that we are able to do 5 plus 5 through these class instance objects that you saw earlier, or 12 times 5 that you saw earlier. So this is all examples of operator overloading in Python. Well, this was it for polymorphism. Under this topic, you've you've gone through topics of method overriding, operator overloading as well. Exceptions, errors that are raised during the execution of a program. When an error occurs, Python generates this exception that can be handled, which avoids our program from crashing. Python has many built-in exceptions. However, we can create many user-defined errors or exceptions as well to catch whatever errors we're looking for in our program. So when an error occurs, Python interpreter raises an exception and stops the current process. And it passes it to a calling process until the exception is handled. And if this is not handled, the program will crash. Some of the built-in exceptions are like IO error, in the case when a file cannot be opened, or import error, Python cannot find the particular module being imported. And there are so many similar, exceptions that are built in Python for the appropriate cases. Now, before we move on and see how we raise these exceptions, let's look at the difference between an exception and a syntax error. So for that, I will be using an example where I will be dividing something by the number 0. Now, of course, this is not possible. So let's see how Python handles this particular problem. Well, it raises what we call a zero division error. And this is an exception that is built in Python whenever we try to divide something by 0. Now let's look at the difference between this exception and a syntax error. So this is the same statement, except I'm going to add this extra bracket, which does not make sense syntactically in this. Now if I try to execute this, as you can see, we get a different type of error known as the syntax error. And it says the unmatched closing bracket. So this is what a syntax error looks like an extra bracket or a comma that basically makes the line unreadable to the interpreter in the first place. So the interpreter doesn't even get to the point where it needs to figure out that there's something being divided by 0. It doesn't even get to that point because it finds this extra bracket and it cannot execute this line at all. So that is like the difference between an exception and a syntax error. Alright, now for our first case of how we raise or how we handle exceptions, let's look at the keyword raise. So for this example, what I will be doing is I'm going to take this variable x, alright, and I'm going to store a value 10. And what I'm going to do is I'm going to check for a condition. If x is greater than 5, then I'm going to raise this exception using the raise keyword like this. And in case this condition is met, if x is actually greater than 5, I want this particular message to play out in my exception. So let's see what happens when I execute this. As you can see, the exception is raised because x is indeed greater than 5, its value is 10, and the error message says as so, that x should not exceed 5, the value of x was 10. So this is an example of how we can raise an exception. And as you can see, when a condition was met, the program comes to a halt and an exception was raised. Now let's look at another type of handling exception, where we use the assert statement. So when we use the raise command, we waited until an error occurred and our program crashed midway, right? What if we want to check if a condition is met? And if this condition is met, then the program can continue. But if the condition turns out to be false, then we want a particular error, namely the assertion error exception, to be thrown to us. So we can use the assert command in such a case. So in our example, we will be checking whether the system that we are working on is actually Linux or Windows 32. So let's see. First of all, let's import a library called sys. This is it's a library where we can access system information. One of the modules in that is one of the functions in that is the platform. It basically tells us what system are we working on. So we're working on a Win32 system. Okay, so let's use the assert keyword. All right, now we're going to check if Linux is what we are working on, and in case it is not, then we want an error message, and this will be the error. The error will obviously be an assertion error because we are using the assert keyword. So this is how we use the assert statement. And if we execute this, as you can see, we get the assertion error because sys.platform contains Win32 and not Linux. And so we got this assertion error. So if we change this to check for Windows system, we won't have any error when we execute this, as you can see. So this is the example where we use the assert statement. Another way of handling exceptions is by using the try and except block. So this is probably one of the most common ways of handling exceptions in Python, where we use a try keyword and an except keyword. Now within the try keyword, as you can see here, we have a chunk of code which we're going to check. And if everything is fine in the try keyword, then this is perfect. So we don't need to move on to what we call the except part of the try and except block. But if say there was an error in the try block, then we move on to the except block where we're going to run the part of the code in the case we find an error in the try block. So first we check the part of the code that is under the try block, and if there is an error, we move on to the except block and we run that part of the code over there. And in the except block, that is where we handle our whatever error that might get thrown our way in the try block. Okay, let's look at an example at how to use this technique. So I have a basic function out here. All right. It's defining a function called Linux interaction. What this is basically doing is that when I call this function, I want to do an assert check. I'm going to check if Linux is the system I'm working on, and if it is not, then I want this error to be thrown. Okay, and so yeah, let's see what happens in the case. And if this assert statement is actually passed, then we will move on to this statement. So you could look at it like this: if when I call this function, it will first check for this assert statement. In case something wrong happens and we get an assert error, then we do not move on to this line. So we only get this printed. But if this assert statement passes, then we move on to this line and we get print doing something. Okay, so let's see. Now I'm going to call this function out here. Let's see what happens here. As you can see, I get an assertion error because obviously this is a Windows system and not a Linux system, and I get this message. Okay, now let's see what happens when we use it in a try and except block. All right, so now I have a try block over here in which I am going to try this function, Linux underscore interaction. If in case I find an error, I immediately jump from the try block into the except block. Now you see the slight difference in how we handle this. Like what happens. So as you can see, when we use the function explicitly, we directly went to what we call an assertion error. But when we use a try and except block, we will not use the assertion error because we are leaving the try block immediately and we're going to go into the except block where the only thing we're doing is printing the statement. As you can see, we are not on Linux, found some error. Okay. Now what if we wanted to catch the error within this function itself, which was the assertion error? And we can do that explicitly like this. So now what I'm doing is I'm going to try, alright, and it's going to catch an error in this, right? So now in the except block, I'm going to say the assertion error that we found in this function in the try block, we're going to use that in our except block. So as you can see, we're going to print that assertion error. It will basically print this statement. Function can only run on Linux systems. As you can see here, function can only run on Linux systems. Function can only run on Linux systems. And the next part of the thing was the Linux interaction function was not executed. Okay, so this is something very important happening here. When we use this assert statement, the whole program is actually getting executed, right? But when we're using the try and except block, we are immediately jumping on, like the moment we catch an error, we are immediately jumping onto the except statement. And all the handling of the exception is done in the except block and not in the try block anymore. So we have to think of it like this, that the try block is only to check if a particular piece of code is does it have any errors or not, and in case it does, then all the handling that we do is in the except block of this particular statement. Now let's look at another example. In this example, I'm going to try opening a particular file. Now this file does not exist, so I will get a file not found error, and this is a built-in exception. And I'm going to catch that and I'm going to print that error over here in the except block. Alright. So as you can see, file not found, and whatever error I have, I printed over here. Alright. So this is another, like, this is a file not found error that we're going to, that we caught in our try block, and we're handling it in the except block. Now let's combine both of the examples where we use this Linux interaction and we also try to open a particular file, and we try to do both things in the try block. And since both of these contain errors, let's see what happens when we have like multiple errors in a try block. So as you can see in my try block, I'm not only doing this Linux interaction, I'm also trying to open a particular file that does not exist, obviously. So now you might think, will I get 2 exceptions? Well, let's see what happens when we try to execute this. So it's important to note that in our except, we have an except for catching a file not found error, and we also have an except for finding the assertion error that is part of this Linux interaction function. So since both of these are erroneous statements, or they will throw exceptions. So now the question is, will we get both of these except blocks, or will we get both of these exceptions? Will we get only one of them? Will we get the first one? So let's see what happens. So as you can see, my error statement is very much like the assertion error that we had done as part of this Linux _ interaction function. Function can only run on Linux systems. The Linux function will not execute it. So as you can see, that is the one that has been caught, and for some reason the file not found error has not been caught. And this is because this is a very important feature of the try block. The moment we find the first error in our try block, we immediately leave and we do not execute any of the further statements, and we jump into the exceptions and we handle it using the except blocks. So the moment an error was found in this function, we did not execute this part of the statement, and we directly jumped into the respective exception. That was the assertion error exception. So this is a key takeaway. So some of the other key takeaways when it comes to exceptions is a try clause is executed up until the point where the first exception is encountered. And in the except clause or the exception handler, we determine how the program responds to this exception. We can have multiple exceptions, and we can differentiate how the program responds to each of these. And it's also very important to not use except clause on its own. It's very important not to use a bare except clause. Now finally, before we conclude this topic of exceptions, let's look at the else and the finally clause. So the else clause is used when we want to execute a particular piece of code in the case where we have no exceptions or no errors found. So let's look at this. Just like we had the Linux interaction function, I'm going to define a win underscore interaction. And this is going to check whether our system is Windows or not. In case it is not, then we get this error message. Alright. And in case it is a Windows system, we print this in the case of when we call this function. So let's again use our try and except statement. Only in this case, we will be using an extra else clause. So we first try this function. In case there's an error, we catch it as an assertion error and we print that error. But if there is no exception, then we move on to the else statement and we print this. So as you can see, we have actually moved on to the else statement and we print this line executing the else clause. And that is because we have found no exceptions over here. So again, it's key to remember that the else clause is used whenever we want to execute a particular statement in the case where we do not find any exceptions in the try block. The finally clause is used when we want to execute something regardless of whether we have an error or an exception or not. So no matter if an exception is raised or if it's not raised, we want this finally block to always get executed. And let's look at let's look at an example of it being used. So I have this block where I'm doing a lot of things. The first thing that I'm doing is I'm going to check for this Linux interaction function, which is going to check, of course, whether it's a Linux system or not. This is I'm doing the try block. Now, if I catch an error, that I want to handle it by simply printing the error over here. And in the event that there is no error, then I will move on to the else statement and I will try this particular block of my statement, which is again that where I'm trying to read a particular file that does not exist. And it's very important that you note that within the else block, I have another try and except block, and this is perfectly legal and it's perfectly valid in our program. We can do this. So think of it like this. I'm first trying this. If I have an error, then I do this and I don't execute this. But if I don't have an error, then I execute this whole statement, which contains its own try and except block. Alright. But regardless of whether I get an error here or not, I will always execute this portion of my statement or under the finally clause. So let's execute this. As you can see, of course, the error is raised in this try block. So we move on to the exception, and that is what is printed over here. And after the exception is done, we move on to the finally. We of course skip this else block because the exception was actually raised. So after that is done, we move on to the finally block where we print this particular statement. Well, that was it for an introduction into exceptions in Python. I hope you learned something from this. And of course, this is just the beginning. Exceptions are something that you will be, that you would probably encounter a lot, especially when you're beginning. And it's something that you will learn to extensively work with. And that will also help you improve in your programming. A function in Python is a group of related statements that performs a specific task or tasks. Now, functions help break our program into smaller and modular pieces of code. And it's very good and very convenient to use functions to make our code organized and manageable, especially as our overall program grows larger. It also helps us to avoid repetition and makes the code reusable. So let's look at the basic way of defining a function. So this is a basic function that I'm calling fun_name. All right. Now, the rest of the function or whatever the task is going to be performed by this function will be written over here with an indent, of course, as a standard when it comes to Python. So I'm going to define this one something in double quotes. So don't worry about what this is right now. This is a doc string. Don't worry about what this means, and I'll explain it to you just in a short bit. All right. Now the rest of the statement, the rest of it will obviously be what this function will do. Let's include a simple print statement. All right, let's done here, and let's call this. So of course, now once you define the statement function, to call the function, you just have to use its name like this. This is how you call a function. So as you can see, when I call this function, it should print the statement hello. Now let's look at some of the like what happened over here. So we've used the keyword def to define a function. We give it a unique name, which makes it with which we uniquely identify this function, and also once we've done this, we can give this function a particular header. It's called a doc string. So what this doc string is basically something that we include in triple quotes over here just after the def keyword, and this is like a brief. We can use this to give a brief give brief information into what our function is doing. So we can say this is this function performs addition, this performs subtraction, or whatever, like some basic information as to what our function does. So we can use a doc string for that. Of course, this is an optional thing. This does not have to be, we don't have to include this as well. All right. But for the sake of this, let's just keep it here. After that, of course, rest of the function will contain whatever task we want to do with it, and that will be indented. Finally, we can also include a return keyword, and what the return keyword does is at any point you find the return keyword in a function, you immediately leave the function and you go back to where this function was called. Okay, so now let's see. Now there's also one more important component of defining a function, and that's parameter. Now if you noticed over here, within these parentheses, I did not include anything. This is like an empty parenthesis, opening and closing. What if I said if I included some a and b over here? So what this means is, whenever I call this function, I need to pass two parameters, a and b. These can be like strings or numbers or whatever. But now it becomes almost mandatory that I pass these two things for my function to work. So let's define a function where I'm going to add a and b. So instead of this print statement, let's do this. I create a variable c, and in that I'm storing a plus b. All right, and then I return c. So you can use a return, and you can return certain like variables along with the return statement. So I'm saying not only return from this function, but also give an output or return an output called c, which is the addition of a and b. Now how do we use this? Well, now instead of just calling the function like this, I'm going to include parameters. So I'm saying pass 2 and 3 to function name, where 2 will take the place of a and 3 will take the place of b. All right. What will happen now is addition will take place and we will get returned the result. So let's see what happens now. As you can see, 2 plus 3, and I got the addition of 2 plus 3, and it returned me 5. So yeah, this was like a basic usage of a function and parameters. So of course, we can, if you want to know like what the doc string of a particular function does or says, you can use this statement. So let's say if So it's very important to like just keep a note in your while you're going through this or while you're learning that whenever we use some sort of a function which has double underscore, right? This is like a built-in command provided by Python within the Python library itself. So these are like built-in commands to check certain details. So I want to check what is a docstring, and this is how I do it. So let's do print. Let's print what is the docstring over here. This is a docstring. So this is basically what I wrote over here. I can change this to this, like this does addition, for example. All right. Now this will say this does addition when I execute this line. So this is the way to check what is a docstring. Anyways, so now that you have seen a basic function or two basic functions that I defined for you and how we use them, what a parameter is, let's look at another concept that we call scope and lifetime of variables. So scope of a variable is the portion of the program where the variable is recognized. All right. Now a parameter and a variable that are defined inside a function are not visible from outside the function. This is a very key thing. So if we define something within the function, we can only use it within this function, and we cannot use it once the function has already been executed, so as to speak. These variables and these parameters have what we call as local scope, since they are only recognized within a particular function. Now the lifetime of a variable is the period throughout which the variable exists in the memory itself. And it's very important to note that lifetime of variables that are defined inside a function are as long as the function executes. Once we return from a function, whatever we have defined within it are destroyed. So when we use a function, it will not remember the values of a variable from a previous iteration of a function call. So let's try to understand this example or this concept using certain examples. So out here I have defined a function where I'm going to create a variable my underscore var, my variable, and I am going to store the value 10 in this, and then I'm going to print. So whenever I call this function, I will always create this variable, I will store 10, and I will print the value of this. Alright. Now what I'm going to do is, I'm not only going to create this my var inside this function, I'm also going to create a variable outside. So you see there, now you might be confused as to, okay, how is the behavior going to be? Because outside the function, I have created my var with a value 20, but inside the function, I will always define my var as 10. Okay. Now I'm going to print. So what I'm going to first do is, I'm going to execute this function that I created initially, where I store the value of 10 in my var, and then I'm going to print the value of my var that was present outside the function. Let's see what happens. You can see two different things happening. So when I execute this function, it prints the value inside the function as 10. But when I print the next line, which says, okay, now get the value of my var, it actually prints a value of 20. And this is a very key concept, because what's happening here is when I initially call my function, within this function, it creates a variable called my var, and it prints the value as 10. And the moment my function has been executed, it destroys this variable, and the variable which contained the value 10 is of course now destroyed, and all we have is the my var that contains 20 from the outside. And when we print that, we get its respective value as 20. So you can also think of it like this. The my var that is present inside this function is different to the my var that we create outside. So the scope of the my var within this function is local only to this function. And once the function is executed, that variable is destroyed. Alright. Now let's look at another case, or the other side of this case, where say we're dealing with variables that have a global scope. How do we deal with them? So let's create a variable called myvar. Alright. And I say I store 100 in this. Alright. Now if I define a function, I've stored myvar. Let's say I define a function. Define underscore, say again, same name, where what I'm going to do in this is I am going to print the value of whatever is there in myvar. Okay, so let's do print value of variable is value stored in variable is. Okay, that's myvar. So let's see what happens when we do this. Let's call this function fun underscore name. Let's see what happens here. So as you can see, the value, I stored a value 100 in myvar, and I've called it inside the function. And this is because since I've defined it outside, I can use it inside as well. Now what if I try to change the value? of this variable inside the function though. So let's see. If I did this, and now if I try to print, let's see, is this allowed? No, it's not allowed. In fact, I get an error. It says local variable myvar reference before assignment. And without going too much into detail, what it's saying is that the variable inside over here is still local to this function. And I have not defined this myvar as a global variable, so I cannot make changes to it within this function right now. And to change that, I can use the global keyword. What if I did global over here? So if I did global, and now if I said, okay, global myvar, and I declare this variable as a global variable, now if I do this, now if I do the same incrementation, now let's see what happens when I'm trying to do this. You see, I get the value 101. This is exactly what I wanted, and that is because I've defined my variable to be a global variable within this function. So I can, in fact, make changes to it within this function. So this is how we use the global keyword and global variable. Also, just to make a quick note, there are three types of functions, the three types of categories in which we can divide functions. First one being built-in functions. These are the ones that are built into the standard library of Python. The other is user-defined functions, that is the ones which we define ourselves. And the third type is called anonymous functions. They're also known as lambda functions, and this is something that we're going to cover in a separate video. Now let's talk about the arguments that we pass in Python. So there are four types of arguments that Python user-defined functions can take. First one being default, the other one is required, then there is keyword, and then there is variable number of arguments. So the default argument is when, say, if I defined a function fun underscore name, and I'm saying a comma b, right? But what if the user has not, say I want a default value of a and b each time when I use this function. So in the case where if, say, I don't pass a value for a and b, like this will always be used. So I can just say a is equal to 2 by default and b is equal to 3 by default. And then within this function, I will say c is equal to a plus b and then return c. So I do this, and if I say fun underscore name, and in case I don't pass any arguments here, let's see what happens. By default, I get the answer 5 because by default a is 2 and b is 3. But this is not fixed, and I can always change this by passing my own values here, 5 and 6, and in this case I should get 11, as you can see here. Now the next type is required arguments, and when we are defining a required argument, we just simply do not use the equal to sign for the parameters over here, and this basically it makes it so that now anytime we call this function, we have to pass something over here. So now if I try to pass like this, I won't get a default value. Then that's because well, there is no default value and it needs an a and b. So I have to pass it a 3 and say 4. Now it should give me 7, as you can see. The next type of argument that we'll be talking about are the variable number of arguments. So let's look at an example here. So what I'm doing in this particular example is I'm defining a function called mySum, where I'm passing some parameter called myIntegers, and I'm doing something out here. And what this does is, it will take the values of a particular collection of objects, and that's called myIntegers. And each value, I'm going to keep adding it to each other, and I'm going to result a particular sum. I'm just going to result the sum of whatever is there. So in this case, what happens is I'm creating a list 1, 2, and 3, which contains 1, 2, and 3, and then I'm going to print the summation of whatever is there. So it should give me 6. Now, the problem in this case is that each time when I'm going to perform this function, I have to create a separate list where I'm going to store these objects. But what if I do not know what exactly I'm going to pass here? What if I don't know if it's going to be a list of objects or what is it going to be exactly? Well, in that case, I can use a variable number of arguments. So it's like a variable keyword argument. So what we use here is a specific way of passing keywords, and we do it like this. So I say define my underscore name, and I use an asterisk. Now I give it any name. This can be args, this can be integers. It doesn't really matter what this is, but this is the key, the asterisk here, and this tells us that whatever we pass here is now we're supposed to create an iterable out of this, and then we can perform whatever task we want. So let's just since I've already created one here, let's see how I'm going to use it in this case. So as you can see, I'm creating a particular variable argument function over here, and I'm doing the same task. I'm just going to keep performing I'm going to add whatever I pass over here. But now when I'm calling this function, I don't need to create a separate list as I did over here. I'm just passing all the numbers that I want to in the form of, like, it's pretty much like a tuple. So I'm just passing these numbers here, and what this function is going to do is going to create an iterable out of this, and then we're going to iterate over it. As you can see, that's happening over here. And I can keep, I can just keep like, so since I've done it for 1, 2, 3, and 7, the summation should be 13 in this case. I can add another number here just explicitly, just like this, and you can see the value will change. And that's because this is a variable, argument method of creating a function. Now the fourth type of function arguments is the variable keyword argument. So let's look at what is the keyword argument now. So I have defined a function here called the concatenate function, and let's see what I'm going to do with this. So in this, I have passed a keyword argument. I've said that, okay, this is going to be a keyword argument function, and what I'm going to do in this is I'm going to create a blank string, and what I'm going to do is I'm going to add or I'm going to concatenate certain strings that I'm going to pass to this function. So in this example, I have passed Python and is and cool and an exclamation mark, all separate strings. And what I'm going to do in this function is I'm going to join them together. And I'm going to create one whole string out of it. Let's see what's the result. Python is cool. So this is, so of course, like if I had to add something else, like Python is say cool, and say I just wanted to say hello and say one more string, I can add it just like this. I don't have to like define a fixed number of arguments. I can pass any number of arguments I want. And this works exactly the same as variable. In the only difference is instead of positional arguments, we're using keyword arguments over here. Hello, bye. Like this, it doesn't really make sense, but just to show you, as you can see. So this is how we use keyword arguments. Well, this is it for this introductory video into functions in Python. I hope you learned a bit about defining functions and sort of the keywords and the components that are part of function definitions, such as keywords and arguments and docstring, for example. You also saw the different types of arguments that we can pass. And yeah, I hope this was a good introduction into what is functions in Python. Now, an iterator in Python is an object that contains a countable number of values, or it's a larger object that contains a countable number of sub-objects. An iterator is an object that can be iterated upon, and what that means is we can traverse from each value and we can manipulate or perform certain functions or operations and tasks using each of the sub-objects or values within this larger collection called iterator. Now, when we're looking at it technically, an iterator is an object which implements the iterator protocol in Python, which consists of the methods iter and the method next. So to begin with, let's look at a simple iterator. We're going to see the example of a list where we're going to traverse through the objects of a list using the for loop. So we have objects 1, 2, 3, 4, and I'm going to print each of these values one by one, as you can see here. Similarly, we can also do the same thing for another iterable known as the string, where we can go character by character, again using the for loop, as you can see here. Another example of an iterable in Python is the dictionary. So let's say I have a dictionary where I have two key value pairs. Key X, which contains the value 1, and key Y, which corresponds to the value 2. Now, when I'm going to do a for loop through this, by default, I will be traversing through the keys X and Y, as you can see over here. And of course, the other types of iterables in Python are like sets and tuples as well. Alright. Now let's look at what this iterating protocol is in Python. So first of all, we take an iterable. It's an object that contains, it's a collection of objects that contain sub-objects. And when we use the iter function, it creates an iterator out of it. So we can, one by one, we can traverse through each of the objects, and we can manipulate each of the objects that is contained in this. And anytime we want to move to the next object, we use the next function. And when we have finally completed all of the, or we've manipulated or traversed through each of the sub-objects, we encounter the stop iteration exception, which tells us, okay, there are no more objects to be manipulated or iterated upon. So as an example, I will create a list where I will store the values, some simple values, integers 1, 2, 3, 4, 1, 3, 4, 5. Okay. I'm going to create an iterator out of this where I will use the iter function, and I'm going to say this is, let's say this is called my iter, okay, and I'm going to use the iter function as I had mentioned, and I'm going to pass my list in this. Now if you see what is my iter, it should be a list iterator at a particular memory location. Now let's use the next function to keep going through whatever is there in this. So of course the first object should be 1, as you can see. Now when I look at the next, it should be 3, then I should get 4, and now I should get 5 as I use the next successively. Now since I've reached the last of my objects in this collection, now the next time I use this next function, I should get a stop iteration exception that is raised, as you can see here. So this is the basic iteration protocol in Python. Now you might have already gone through the for loop video, and in that I have spoken in quite a bit of detail as to how a for loop performs this iterator protocol and how it creates an iterable object out of, say, a list or a tuple, and how it internally performs the next function, and it breaks out of the for loop once it encounters the stop iteration exception. So for loops are like, they're very, very similar to your standard iterator, and they use pretty much the same protocol for its functioning. Now let's do a basic comparison of what is a basic comparison between a generator and an iterator in Python. So in generator, we use a function. We define it using the def keyword, and we define it under one function to create a generator. Whereas in the case of iterators, we use two separate functions, the iter function and the next function. The generator makes use of the yield keyword, whereas the Python iterator does not. In generators, we save the states of the local variables each time we use the yield keyword, and we pause the loop temporarily. Whereas in iterators, we do not make use of any local variables. All we need is an iterable like a list to iterate upon. We may use any number of yield statements in generators, and we do not use yield statements in iterators. Generators are not memory efficient, whereas iterators are very memory efficient. So this is like basic comparison between generators and iterators. So this was it for our introduction into iterators in Python. Now a module in Python, to put it simply, is basically a Python file that has functions and classes written into it and is saved with the .py extension to specify that it is indeed a Python file. A Python program can use one or more modules, and modules can have one or more functions. They basically help us organize our code, and instead of having one long Python file, we can have several files or several modules. Now modular programming is the process of breaking a large event or task into smaller and more manageable subtasks, and we call these subtasks basically modules. Now individual modules can be grouped together like building blocks to create a larger application. There are several advantages to modularizing code in a large application, and we will be going through them right now. So first of all, there is simplicity because instead of focusing on a big problem or big task, we can break down the problem into smaller portions or modules. Now maintainability of code is much better through modules because they are designed to create these sort of boundaries or clear demarcations between different problem domains. There is reusability in the sense that once we create a module, we can use it in different parts of the code or even different applications itself. There is also scoping, and what this means is modules typically define a separate namespace, and this helps us avoid collisions between identifiers in different areas of a program. Functions, modules, and packages are basically all constructs in Python that promote code modularization. You might have already come across or gotten an intro into functions. In this video, we will be going through modules. And in another video, we will also cover the topic of packages. To import a module, we use the import keyword. And in this example, what I'm going to show you is a simple function or a simple operation of importing the OS module. This is short for operating system. And as the name suggests, we can perform system tasks through the functions and methods that are part of this OS module. So simply executing the statement will import this module onto our program for us to use. Now, if we wanted to see all the functions that are present in a module, what we have to do is use the dir function. So if we print the dir OS function, it will print us basically a directory of all the functions that are present in the OS module, as you can see here. All of these are basically names to different functions that are part of the OS module. Finally, moving on, another function commonly used with modules is the getCwd function. And what this does is it will give us the current working directory that we are working upon right now. So if I execute this, it will tell me what is the directory that I am currently working upon right now. As you can see, C notebook dir/temp. If we wanted to see all the files in a particular directory, what we can do is use the listdir function followed by giving a path. By default, if we do not enter a path inside the parenthesis, it will basically give us all the files in the current working directory, which in our case is temp. So if I were to execute this, it basically gives me a list of all the files that are presently there in the directory that I am currently working upon. Now a basic step is creating a Python module. The simplest way to create a Python module is basically creating a Python script with whatever functions and tasks that we want and methods that we want inside whatever module, and saving it with a .py extension. So in my example, what I'm going to do is I have already created a script in Notepad, and I've stored it with a .py extension that contains these four functions: add, subtract, product, and division. I've basically used this code and I've stored it in a .py script, and I'm going to be using this as my as a test module for this particular example. Now, how do we import a module? Now, once that I have created a script, in my example, it will be called mycalc.py, and we've stored it in our directory. To import the module, all we have to do is use the import statement. So if I have to import mycalc, all I have to do is say import my_calc, and now my calc has been imported. So we can use the import statement, or if we want to import something particular from mycalc, we can do from mycalc import. Now we can, whatever, like for example, if we wanted the add function, we can basically just say only add, or if we wanted add and subtract, we can say add and subtract, for example. So this is basically by using from, we can say that we want something from something, but only parts of it. We don't want everything. We can also use from mycalc import, and we can say asterisk to basically say import everything that exists in mycalc right now. So this is another way of importing something from a module. Now, to access contents in a module, we have to use the dot operator, and I will show you how right now. So what I'm going to do is, in my example, I'm going to import mycalc as calc. So now since this is the original folder or the original module, but I'm going to give it a shorthand name so that I can easily use it in my code and I don't have to type out my_calc every time. So now I'm going to import this as calc. So anytime I have to refer to a particular method or function inside this script or this module, I will just use this placeholder, this variable name. So now I have two variables, a and b, and I'm storing 20 and 30 in them. So my first what I'm going to do is basically four operations. I'm going to print the addition of a and b, then the subtraction, multiplication, and the division of these two numbers. And each time to do this operation, I am going to use the add function that is present in the mycalc module. So to do that, I have already imported mycalc as calc. All I'm going to do now is invoke these functions using the dot operator that we are already familiar with. So I'm going to say calc.add, and then I'm going to pass these two arguments or these two variables to say that I want to add these two. And similarly, I'm going to do it for subtraction, multiplication, and division. As you can see, these are the results of my tasks. Now, if I had to do a directory operation on the module calc, it will basically give me a bunch of inbuilt or Dunder methods that are already a part of any Python script by default, such as built-ins. So if I execute this just to show you what happens when I use the dir function, it will basically give me all the functions that are part of this Python script. So these double underscores that you see are basically denoting magic methods or Dunder methods, and these are like inbuilt methods as a part of the script. And if you see here, add, division, prod, and sub, these are the methods that we have defined earlier on in our script ourselves. Now, to go slightly deeper or in more detail into what happens when we do a module search, let's actually look at what happens. So what happens is when, for example, we execute the statement import mycalc as calc, as we did over here. So the steps that actually take place are the interpreter executes the above statement, and it searches for this Python script in a list of directories assembled from these following sources that you see here. So it takes the directory from which the input script was run, or the current directory, if the interpreter is being run interactively, which is the case right now. Secondly, it will list all the directories contained in the Python path environment that you set up, that you can set up or you can change later on as well. And this format for Python path is OS dependent, of course, but it should mimic the path environment variable that we see in Windows systems. And then the other source or the other directories is basically an installation dependent list of categories configured at the time Python is installed. Now the resulting search path that is accessible in the Python variable system.path, this is basically obtained from a module named sys. So if I imported this sys and I did sys.path, now these are all the directories that we are going to look for when we want to search for any particular module. So if I'm doing import mycalc or import os, it's not only going to look at the current directory that I am working on, it's also going to look at all of these directories that have been set up as you could say directories or paths in the system.path. So yeah, this was a brief video on Python modules. I hope you learned and you got an introduction into what are modules and how we use them in Python. Now what if we developed a very large application in Python that contains many different modules, and we have so many different modules that have similar names and functionalities, and they're all kept in or dumped in the same location, that it becomes very difficult to track these modules. What if there was a way to organize and access these in a much simpler and more organized manner? Well, packages allow us to do just that. Packages are a hierarchical structuring of the module namespace using dot notation. And this is the same dot notation that we use when we want to access methods or functions that are part of other classes or modules. So let's look at certain examples to understand what we mean. So I have a directory called pkg. This can be basically treated as what we call a package. Now in our package, we have two modules, mod1.py and mod2.py. And what we're going to store in mod1 and mod2.py are the follows. So I'm going to define a function called foo, and I'm going to print this particular statement, mod1, and then I'm going to basically say foo. And then I'm going to say in class foo, I'm going to have an empty pass command. Similarly, I'm going to define a function called bar in mod2.py where I'm going to print this statement. So basically mod1.py has a simple function where I'm going to print this statement, and mod2.py has a simple function that I'm going to print this statement. And I'm going to store them in mod1 and mod2.py respectively. And these two modules I'm going to store in the directory pkg in my local folder. Now I've already done this, so we can already get to working with this. Now if I wanted to access these particular modules from the pkg folder, I can simply use the import command and use the dot notation. So I can say pkg.mod1. So this will import the mod1 module from pkg folder. Similarly, I can do the same thing for the mod2 module from the pkg folder in the same line. So now that it's been imported, just simply execute this, and this imports whatever you needed. Now, if we wanted to perform a function that was a part of mod1.py, we can just extend the dot notation and use the function as over here. As you can see, it performs this print command, whatever it was supposed to do. Similarly, I can invoke the function that was part of the mod2 module by extending the dot notation to it in the same way. Now, another way that I can invoke I can import a package is by directly importing the package itself by using import pkg and not accessing any of the specific modules within it. Now let's see what happens when we do this. So just for this example, what I'm going to do is I'm going to restart the kernel so that the pkg modules that were already imported get cleaned away. So we see what happens when we execute this on its own. Now if you see, I have imported this. Now let's see if I can access my mod1 and mod2. Now if you see here, it's throwing me an error. And this is because simply using the import command on a particular package only imports, you could say, the package namespace, but it does not actually import any of the modules and files that were part of this package. So if I wanted mod1 from this package, I would have to actually say import pkg.mod1 directly. And I cannot simply say import pkg and Python will not import everything that is part of a package on its own. I have to specify it myself specifically. Now I'm going to create, and I'm going to show you another type of importing from a package using the star operator. So I have this package pkg once again. Now I'm going to store 4 different modules within this package: mod111.py, mod222.py, and I've already done this. So you don't need to bother about seeing me doing it right now, because I've already created these files, and what I've done is within mod111.py I've written this statement and I've stored it in the Python script. Similarly, I've created another Python script called mod222.py, and I have basically written this in the code. And I've similarly done this for mod333.py, and I've done another for mod4.py. Now, once I have done this, I've stored these Python scripts into my package or pkg package. So now what I'm going to do is I'm going to execute this command. If you see this, from pkg.mod333 import star. So once I execute this, now I'm going to say print directory, and print directory basically will tell me all the functions that exist in my current directory. If you see here, there's this baz function that was a part of mod333 module. Now if I change this and if I imported mod111, and if I did the same thing, you will see foo has now been added as a part of this directory. And these are all functions that were part of these different modules where I'm importing from. And that is what the star function does. What the star function will do is it will basically tell Python, okay, so the statement is saying from pkg.mod111. So it's saying that, okay, look into this directory or this package and find this module. And in this module, import everything that exists inside it up until this point. So this is another way of basically importing files or functions from a particular package and a particular specific module within that package. So yeah, this was a very brief video on packages in Python. The conclusion being that packages are basically an organized way of storing many different modules that we might have created in a very large application. And these modules can be accessed using the familiar dot notation that we have used in other examples, such as methods when we were working with classes and objects. So let's start with this. So this question that we have is, we have this program that we have to write where we compute the frequency of words that exist in some input. Okay, the program should output after sorting the key alphanumerically. Now this input can be it's basically a block of text, right? So in our example, we have, for example, if this was our input, right? What we want to see is an output which is basically saying that the word Python has appeared, say, well, in this example, it's appeared 5 times, and then the word read has appeared 1 time, and so on and so forth. Like for each of these words, we want to see how many times have they appeared in this particular block of text. So let's look at a particular example now where we have done this. So let's see here. So first of all, I'm going to create a dictionary. So why am I creating a dictionary is because I'm going to use each unique word as a key and the number of times they have appeared in a block of text as the value to that key. So I'm going to use a sample string, which is basically this long string that you can see here, which is stored in line. So this large chunk of text is what we're going to be analyzing. So how are we going to do this? It's pretty simple. So we have this. Now what we want to do is, when we find one way of tackling this problem that we're going to do here is we want to check word by word. First of all, we want to see if it's a unique word, and if this word is, before I encountered it for the first time, then we need to store a new key in our dictionary called frequent table or frequency table. And if it has already, if there's a key already with that particular name, then we just want to increment the count or the value by 1. So let's see how we do this over here. So if you can see in the solution is as simple as this, but if you see what's happening, it's basically what it's doing is we're splitting up this string using the split function. What this will do is it will split up the string at every white space. So it will take this as one part, it'll take this part as another part. It will create an iterable with each word as the each iterable object in that container. So it's going to be a list of words like Python is 1, so on and so forth. And we're going to go one by one. So we're going to say for word in line.split. Now if this word if it exists in frequency table as a key, then what we're going to do is we're just going to increase the count of the value of that key by 1. But if it does not exist, then we're going to actually create a key with the word as that unique word, and we're going to create its value, initialize its value to 1. So when we execute this, now if we want to, once we've done this, we can sort it by the count of the words. So what we're going to do is we're going to create another tuple called sorted tuples, where we're going to use the lambda function out here to sort the dictionary in terms of its values. So what we're going to do is we're going to take the key being the lambda item with index 1. Index 1 is basically the value. So a particular key has a value. So the word Python appears so many times. The word, say, scientist appears so many times. So we're going to check which words have the highest number of occurrences, and we're going to sort it in a descending order. So that is basically what the reverse is equal to true does. So when we're going to sort this, when we're going to use the sorted function, when we say reverse true, it tells the sorting function to sort this dictionary frequency table in terms of value by the descending order. So whichever word appears highest, that would be the first word in our sorted tuple. So that's what we do in this line, and once we execute this, we're also going to print. So if you see the result of this activity that we've done, you can see that the word machine appears 6 times, learning appears 6 times, then Python appears 5 times, and so on and so forth. So we've created a sorted tuple where the first object of the tuple, we've created a list of sorted tuples where the first object of the each tuple is the unique word. The second one is the number of times that it has appeared in this particular example or this particular string. So yeah, this was the first basic project that we have tackled. In this, you might have seen some examples of how we do list operations and how we use the lambda function in sorting the dictionary by the values of the key. What we're going to do is we're going to tackle another slightly complicated a question or a situation. We're going to try to arrive at a solution. So in this, what we have is some sort of a robot, a moving robot, which moves on a Cartesian plane, a 2-coordinate plane, is going to move in terms of up, down, left, and right. Okay, and each time it moves up or down or left or right, it takes a certain number of steps in that direction. Integral steps, of course. So what we need to do is from its starting position, whatever its starting position is, which we're going to take as 0, 0 in this example, we're going to make it move to a particular location with the commands up, down, left, and right, followed by certain steps. And we're going to what we're going to do is we're going to calculate the distance between these 2 points. And we're going to calculate different types of distances. So you might be introduced to new concepts, new distance concepts in this video as well. So what we're going to be using for distance calculation is the Minkowski distance. And that is, we're going to take, so the Minkowski distance between 2 variables is basically the absolute difference between these 2 variables, so these 2 points, and we take it to the power of something. So if we want to say calculate the Minkowski distance with, in terms the quadratic Minkowski distance with basically P2, so we are going to do xi minus yi, absolute difference to the power 2, and then we're going to take the second root of it after summing each and every point. So when we take p is equal to 2, we say the Minkowski distance behaves like the Euclidean distance, and this is probably one of the most common distances in case you've done basic Cartesian geometry. When you're asked to find the distance between 2 points on a plane, we can also take the absolute distance where we take p is equal to 1. So in this case, we're just basically summing the absolute distances between each point. No roots, no powers, nothing. Basically p is equal to 1, and we call that the Manhattan distance. So we're going to take p is equal to 1, 2, and 3 in each case, and we're going to find the distance between 2 points based on these measures. So this is just a visual representation. This is basically the Euclidean distance, is basically the estimate of the value between these 2 points. If since this is a 2-coordinate system, whereas the Manhattan distance would be the absolute distance in terms of if we go up and then we go right between these 2, like say if this was and this was another point. So yeah, let's move on to the problem. In this particular example, we're going to start from the starting position 0 and 0 on a graph. And we are going to give the commands of up 5, down 3, left 3, and right 2. So first of all, what we want to do is we initialize the starting position as 0 and 0. And we also, just for the sake of this example, we initialize the end position as 0 and 0. So what we're going to do, first of all, is let's execute this much. Now we have this list of tuples. We're going to call this actions, and this is the actions that we're performing. So each tuple contains an action and the number of steps in that direction. So it contains 4 actions: up by 5 steps, down by 3 steps, left by 3 steps, right by 2 steps. So now we're going to iterate over this each tuple, and we're going to get the direction first of all in this line for each step, and we're going to calculate the number of steps it takes. So for each action, it's going to first tell, it's going to check what is the direction which is done by this line, and we're going to find out the number of steps in that direction, which is stored in this line. So once you've gotten this, for each action, we have to update the end position, right? So what happens is if you go up by a particular direction, so you are basically changing the y-axis, right? The y-axis. So we're going to change end position and the first index, which is basically this part of the end position coordinate point. So we're going to say if it's moving by up, then we're going to update by adding the y-axis by the number of steps. So and if the direction was down, we're going to do the same thing for the y-axis, but we're going to decrement it. Similarly, if we move left or right, we're moving the x-axis, right? So we take end position in the first index. So we take the x-axis, and if we're moving left, it's a negative, it's a decrement, and if we're moving right, it's an increment. So if there's any other action, like any other action, for example, that was given here, we say pass. So basically, the only valid actions that we can pass is up, down, left, and right. Otherwise, we just skip that particular action. So this is what this particular loop will do. It will update our final position. So once we've done this, if I execute this, what will get stored in the end position is basically my end position. So now that I have my starting position and my end position, just to show you what the end position will look like right now, let's just do this. So if you see here, after I've moved up by 5 steps, down by 3 steps, left by 3 steps, and then right by 2 steps, my final end position is -1 and 2. My start position, on the other hand, was, as you remember, it should be 0 and 0. It is 0 and 0. So now we're going to find the distance between 0 and 0 and -1 and 2. So we're going to first of all create a function called Minkowski distance, which does a basic function of just calculate the difference between the the end position x coordinate and the end position y coordinate times or to the power of a root. And we're basically going to do this operation that you saw here. We're going to do this, and we're going to use this root variable to specify to p is equal to 1, 2, or 3, what p value we want to take for this Minkowski distance. So once we've done this, what this function will do is basically store this much, and it will wait for us to give us a root. So when we give root 1, it will create these, it will check the distance between the end and the starting points with the p value of 1. If we give it 2, it will calculate Euclidean distance with p value 2. Similarly for 3, and we can calculate for any roots. So we're going to calculate for 1, 2, and 3 roots, and we're going to see what values we get in each case. So when root is equal to 1, I print a statement saying Minkowski distance with root 1 is something, and then root 2 is something, root 3 is something. Let's see what results we get. So if you see here, the Minkowski distance with root 1 is actually 1.0, but the Euclidean distance between these 2 points is 2.23, whereas the cubic Minkowski distance with with root 3 is 1.91. So you see these 3 different distance measures for the same distance between 2 points. So in this video, by doing this activity, you will learn how to iterate through loops and perform these distance calculations, which you'll find pretty handy in many activities related to data science and machine learning. So let's look into our particular question. We have a website that requires users to input username and password to register. Now we have to write a program to check the validity of passwords input by the users. Now the criteria that the passwords have to follow are that there's at least 1 letter between A and Z and 1 number between 0 and 9. The third criteria is that there's at least 1 letter between capital A and capital Z. So this first and third point basically is saying that there should be 1 lowercase letter and there should be 1 uppercase letter. Now there should be at least 1 character from $, hash, or the @ symbol. It should have a minimum length of 6 and the maximum length of 12. So when whatever passwords that we enter into our example, they must be comma separated. So if we're going to have an input, they're going to ask us for an input where we're going to have to input the different passwords in a comma separated way. So let's look at how do we tackle this. So for my example, I'm going to use these examples. in terms of these are my password examples. If we're going to check if these are valid passwords or not. So let's copy this first of all. And now let's import the RE. This import RE is basically the regular expression module. Now in this step is going to ask us to input the passwords, as you can see here. So I will just Control V. So since this is comma separated, what it will do is it will split up each of these by the comma, and it will store them in a list. So it will take this as one password, this has another password, this has another password, and this has another password. Once I press enter, now if I want to check what's in list, what's in items, what I can do is just check over here what's in items. It's a list of whatever passwords I had entered. Each object is separately treated now in this list. Now I'm going to create an empty list called value first of all. Once I've done that, I'm going to move on to the next step. So once I've created my list called value, what I'm going to do is now I'm going to search and I'm going to check for each condition using regular expressions for whatever criteria that we have initially. So if you see here, what I'm going to do is first iterate by each item in this to check for each password. Now my first check will be a basic check for the length of the password. If it's lesser than 6 or greater than 12, then our password is illegal. So we can't be using this and we will just continue and we won't check for anything else. But if it is within 6 and 12, the length 6 and 12, then we can continue with our check. So we'll do an else statement for pass, which basically moves on to this next block. Now, once we've done this, what we will do is this first statement, what this is going to do is going to do an re.search. And re.search, as you know, is going to look for at least one instance of a letter occurring between A and Z. So this re.search followed by this. Now this is the regular expression that we have passed, and what this tells us is basically the square brackets, we're looking for anything between A and Z in terms of small letters. So if this condition is not met, then again we continue and we leave this particular search because one of our criteria is not met. Alright, but if it is met, then this if not statement will not we won't enter this block and we can move on to the next check. So now we move to elif not. Now again we're using if not statement. So this is basically checking for a negative case. So anytime one of these cases have been met, it basically means that our password has been invalid because these conditions are not being met. So we're trying to eliminate all of these conditions so that we get a valid password. So again, we move on to the next statement, which is basically going to do the search for numbers. Once again, if we find a case, a password without any numbers, we continue and we don't check this password no more because we already know it's an illegal password. Now next check will be for capital letters A to Z, and the next check again will be for these particular symbols, the $, the hash, and the @ one of these three symbols. We're going to search for a white space character. So if we actually do find a white space character in our password, that's an illegal password and we're not going to continue checking for those cases. So this is basically all our cases: lowercase letters, numbers, capital letters, one of these three symbols, and the existence of a white space. So once we've done all these checks, if none of these have been passed, we move on to this else statement where we just pass. And what we can do is we append the value p to the list called value. So basically what happens is, just to go through it again, if this condition is not met and this condition is not met, this is not met, this is not met, this is not met, and if this is also not met, then we're fine. So basically, as long as we have small letters, as long as we have a number, as long as we have a capital letter, as long as we have one of these three symbols, and as long as we don't have any white space characters, we can append p to this. Otherwise, it will continue and it will break out of this for loop completely. That's what the continue statement at the end of each of these blocks checks. Anytime this condition is met, this if not condition is met, then we break through this whole for loop and we don't append p to the value. But if we actually get to this stage, then what we can do is simply append p to value. Now finally what we are going to do is we're going to print out all the valid passwords. So just by a quick look, you can see here this is a valid password, right? So let's execute this and let's see what we get. If you see here, we only get one valid password, and let's look at why some of these did not turn out to be valid. So if you look here, all of the conditions are met. It has a capital letter, it has a small letter, it has at least one number, and it has one of the symbols, either $sign or the hash sign or the @ sign. In this case, we have two white spaces, one over here and one over here. So this is an illegal password. Similarly, in this case also we have an illegal password because it begins with a space. In this case, it's the same thing. We begin with a space, and also it does not have any of those symbols that we were looking for, the $ or the hash or the @. So again, so these three are illegal passwords and they do not get appended to value. However, this does get appended to value, and that's why we get the result for only one password, which is the only legal password.
Pygame is a cross-platform Python software which was made specifically for video game designing. It includes graphics, visuals, and sounds which can be used to enhance the game which is being designed by you. Officially written by Pete Shiners to replace PySDL, Pygame is suitable to create client-side applications that can be potentially wrapped in a standalone executable. To learn Pygame, it is required to have a basic knowledge of Python. Now, how do you go about installing Pygame on your system? To install Pygame, you can use the standard pip install command in your command prompt. Then, you can import it into your program with the import command prompt in Python itself. Before installing Pygame, Python should be installed in the system. It is good to have Python 3.6.1 or above versions because it is much friendlier to beginners and additionally runs way faster. Now, what are the basic components of Pygame? The first and most important component of Pygame is the pygame.init module. This is used to initialize all imported Pygame modules. Using this, you can call all Pygame modules at once into your program. Before you can do much with Pygame, you need to initialize it. The most common way to do this is to use pygame.init. This will initialize all the modules in Pygame with just one single command. Not all Pygame modules need to be initialized, but this will automatically initialize the ones that are important and the ones that have to be initialized. You can also easily initialize each Pygame module by hand. The next thing that you need to know about is the display surface. The display surface is a black screen which acts as a canvas for you to design your games on. All the game components will appear on this very screen. Now, Pygame has a single display surface that is either contained in a window or runs full screen. Once you create the display, you can treat it as a regular surface. Changes are not immediately visible on screen. You must choose one of the two flipping functions to update the actual display. The Pygame display can actually be initialized by one of several modes. By default, the display is a basic software-driven frame buffer. You can request special modules like hardware acceleration and OpenGL support. Now, Pygame can only have a single display active at any time. Creating a new display will close the previous display. Once the display surface is created, the functions from this module affect the single existing display. The surface becomes invalid if the module is uninitialized. If a new display mode is set, the existing surface will automatically switch to operate on the new display. The next concept is the game loop. The game loop is a piece of code that does three things. It will handle events, update game events, and draw game state to the screen. The game loop will basically run until a condition is met or until the game ends. And finally, you have pygame.quit. The pygame.quit function does the opposite of the init function and completely deactivates the pygame library. It will automatically uninitialize all Pygame modules that have previously been initialized. When the Python interpreter shuts down, this method is called regardless, so your program does not always need it. except when it wants to terminate its Pygame resources and continue. It is safe to call this function more than once, as repeated calls have no effect whatsoever. Now please do note that calling pygame.quit will not exit your program. Consider letting your program end in the same way a normal Python program will end. It will just help you break out of the game loop. Now, let's see how we can create a Flappy Bird game with the help of the Python Pygame module. So the first thing that you're going to need is to call all of your required modules. So over here, we have imported the random and the sys module. We've imported the Pygame module. And we've also imported all the modules which are present in pygame.locals. So let's run this so all the modules get imported into our program. There we go. Now all of our Pygame modules have been imported. Now the first thing that we're doing is that we're setting global variables for the game. The window width and the window height basically determine how big our surface is going to be. After that, we're going to display our window. Now you can call or create a window by using pygame.display.setMode. And within set mode, you set your window parameters. So you set your window width and your window height. So here we will be creating a window of width 600 and of height 499. The elevation will basically tell you how far up from the bottom of your screen the window is going to be. We're going to be creating an empty tuple of your game images, and we're going to be having an FPS of 32. You can obviously change your FPS speed. Now all of these images that we're importing have already been downloaded onto your system. So all of these images are already here, and they're in the same folder that we've stored our Flappy Bird game in, which is why to call them you simply have to write the name of the image and initialize it to a variable. So because we're creating Flappy Bird, we're going to have a pipe image, a background image, a bird, and obviously a base which is going to be a sea level and which you have to prevent the bird from touching. So let's run this and create nothing but our Pygame window. So here, as you can see, a new window has come up. This so far is just our Pygame window. Nothing has been shown on it because we haven't initialized any of these parameters into our window as of yet. So far, the only thing we've done is create a basic window which doesn't have any of the parameters on it, with a width of 600 and a height of 499. Now here we are going to be coming into our Python game loop. So the first thing that we talk about in our Python game is that you have to have some initialized variables, right? And you have to create some important components of the game. So the first thing that you have is the Flappy game, which is the game itself. The next thing that we have here is to check if our game is over. This is going to happen under two conditions. One is that the bird hits the pipe, and the second condition is that the bird falls into the sea. And finally, we will have a module to create pipes of random height as and when a bird goes further into the screen. So basically the pipes will be created as the user keeps going and not beforehand. And finally here we have our main game loop, which is going to be calling all of these various functions that we've created and which is going to terminate their runtime the second that the game gets over. And then following this, we're going to be exiting the Flappy Bird game. So here pygame.quit, as you can see, as we've already told you, will close all of the Pygame modules that you've already initialized in your program and will uninitialize all of these modules, while sys.exit will exit the program itself. Now, as we said, the pygame.quit doesn't quit the program, it only uninitializes all the Pygame modules, which is exactly why we're using sys.exit to close our window and exit our program. Now, the first thing that we're going to be looking at is the Flappy Bird game itself. The main things that are happening in our Flappy game is, first of all, we're initializing variables and creating two pipes by calling the create pipe function. So at any given point, we know that we want our bird to fly in between two pipes. That is the main challenge here, which is exactly why we're initializing two pipes here, the first pipe and the second pipe. And this is done by calling the createPipe function. Now after this, we're going to be creating two lists. One is of the lower pipes and the other is of the upper pipes. Now as we already talked about, we are going to have two pipes consecutively. Yeah, the first pipe is going to be on top and the second pipe is going to be at the bottom. So that's exactly what these two lists contain. They contain the height at which the down pipes and the up pipes are going to be. Or basically they contain the coordinates at which these down pipes and up pipes will be displayed at. Now pipe vel x is basically defining the pipe velocity along your x-axis, and the bird velocity, which is along the y-axis, is defined over here. So basically your bird is going to have two different parameters. One is that it's going to move up and down, which is its velocity along the y-axis. Another is it's going to move across, which is its velocity across the x-axis. Now at the same time, the pipes also have to keep moving and they have to exit this frame. So that's what all of this is defined by. The bird acceleration is defined over here. This is the parameter that you're going to be using to define your bird acceleration along the y-axis. That is basically going to happen when you stop clicking and the bird starts falling downwards. Now the velocity while flapping, or the x-axis velocity for the bird, is defined over here. Now the bird is only going to be flapping when you're going to be pressing the key. So that's basically what you're going to be checking here. If your event takes place, which basically means that if you have key events, and that's exactly what pygame.event.get is doing. It's going to be getting all the key functions that are taking place on your keyboard simultaneously. So for event in pygame.event.get will basically help you get the keystrokes which are happening. If event type is equal to quit, or event type is equal to key down, and event.key is equal to k.escape, you're going to quit your game and you're going to close down your program. So there are two ways that you can quit your game. You can either press quit or you can press key down and escape. Now if your event type is equal to key down and your event.key is equal to space or k up, so this is basically what you're going to be using to make sure that your bird is moving. There are two main keys which are going to be coming into play over here. You can press the key down as well as the space key, or the key down and the up key. So over here this is going to move your bird vertically, and it's also going to make sure that your bird flaps its wings, which is where the bird velocity, which are all these parameters, will come into play. So this will basically help your bird move forward. So basically what is happening here is that we're going to be getting the keys that the user has pressed, and if they've pressed the quit key, we're going to quit the program, and if they've pressed key down and space or key down and the up key, we're going to make sure that the bird starts moving in the y-axis as well as it starts flapping its wings and moving along in the x-axis. Now this is the function that checks for whether your bird has crashed into pipes or not. This is basically also going to define whether your game is over or not, right? Because once the bird touches a pipe, the game is basically finished. So game over here is game over, which is another function that we are defining here. So basically what's happening over here is that you're going to be checking if the game is over by checking the horizontal and vertical position of the bird and the positions of the up and down pipes. If the game is over, then you will return over here and you will basically quit the whole game. Now after this, we need to keep track of the score of the player. Now how that can be done is that you get your position of your bird and the position of your pipe, and if the bird has crossed the pipe, then you basically increase your score by 1. If the current velocity of your bird is less than the maximum velocity and the bird has not flapped or you haven't pressed your key, in that case, the bird is basically going to be tumbling downwards. Now, another thing that you have to consider is that the user has stopped pressing the key, right? So the bird is not going to be flapping its wings. If this is the case, then the bird has to free fall towards the sea basically. So this is how we're going to be checking it. If the velocity of the bird is less than the max velocity and the bird has not flapped its wings, what we're going to be doing is we're going to be increasing the present velocity of the bird in increments with an acceleration speed that we've already defined over here. So if the bird starts flapping its wings, the velocity will steadily increase with this acceleration. Now, if the bird has flapped its wings, after that, we need to set the bird flap function to false again. Otherwise, it will continue being true, which is not the case. So we have to keep switching it, right? The bird flap will only be true when the user has pressed the key. After that, it immediately has to go back to a false variable. So that is basically what we're doing here. We're going to change the bird flap to false immediately after it has become true. Now after this, your pipes will keep moving to the left. In this game, the pipes are the ones that are moving horizontally. The bird is not moving horizontally. The bird is only moving vertically. So basically what we're going to be doing is we're going to be increasing the x coordinate of our pipe, and the pipe is not going to randomly start increasing in height, right? So we're not going to be touching the y coordinates of the pipe. Of the upper and the lower pipe, we're going to slowly increment the x coordinate by the velocity factor that we've already initialized previously. So the pipes will slowly keep moving by this velocity factor towards the left hand side of the screen. A new pipe will be added when the first is about to cross the leftmost part of the screen. So basically, each pipe is covering about 5 points on the x-axis, and once it is less than 5 but still greater than 0, we're going to create a new pipe. And we're going to append it to our up pipes list. And we'll also be creating another pipe and we're going to append it to our down pipes list. Now, if the pipe is out of the screen, we basically have to remove it. And this we're going to do by popping out the pipe from the up pipe list. So far, we've looked at how we can generate pipes for our window, the velocity of the bird when it is flapping its wings, and what is going to happen when it stops flapping its wings, handling the key pressing events that the user is inputting, checking whether our bird has crashed or not, updating our score, moving the pipes to the left, and creating new pipes once the previous pipe has left the screen. Now, the only thing that's left to do is build a game image window, because we've dealt with almost all the game logic that we need. So now we're basically going to start building our Pygame window. So first we're going to be putting the image all throughout the screen. We're going to be rendering the up pipe and down pipe at the respective positions on the screen. And then we're going to be putting the sea level and the bird on the screen. Another thing that you need to do is fetch the digits of the score and display them on your screen. So the digits, again, all of the images have already been included in our Flappy Bird folder, and all you have to do is display them onto the screen. To do this, all that we have to do is loop through our numbers list and display the scoreboard images on the side of our window. And this is the position at which they'll be displayed. So here we're just displaying the images on the screen. The offset is again just a variable that we've created here, and that's the variable at which we'll be displaying the images. Now every time the score changes, you're going to have to update the game window. So that is exactly what you're doing here. You're just updating your display game window. And as we talked about, every time your display changes, you can't have two displays open at once, so the game will move on to this new display window. And again, over here we're just setting the frames per second. And that brings us to the end of everything that we need to do. This is the basic game logic that we're going to be needing. So this whole function just defines your game logic. Let's finish running this. And your game logic has been initialized into your program now. Now the next thing that we have to do is check if our bird is above sea level or if it has hit any of the pipes. So this is what you use the isGameOver function for. So the isGameOver function will have 4 different parameters as input. So the isGameOver function has 4 parameters. You're going to be giving the horizontal and the vertical height of the bird and the height and position of the up pipes and the down pipes. Now there are basically 3 conditions which lead to a situation of the game being over. If the difference between our elevation and a certain height is less than the vertical, it means that the bird has crossed its boundaries. And that is why the game is over, which is where you return true. The another thing is that the bird hits either the up pipes or one of the down pipes. And that's what we're checking here. Either the elevation of the bird has decreased and there's no way that it can rise up again and hence the game will be over, or the bird has hit one of the pipes on top or one of the bottom pipes. So that's basically what we're doing here. We're getting the height of the up pipe and we're checking if the vertical height of the bird is less than the pipe height plus the pipe width. So basically it can hit the pipe anywhere, right? So if this vertical height is less than this parameter, as well as if the bird doesn't hit the pipe horizontally. So that's what we're basically checking here. We're checking to see if the bird has hit the pipe horizontally or vertically. Then you will return true. And the same thing will happen for the down pipes. You will check if the bird has hit the pipe horizontally or vertically at any point. So let's run this GameOver function. The next thing that you have to do is the create pipe function. Now creating pipes is actually quite easy. All we have to do is fetch the height of the pipe using the getHeight function, and after that generate a random number between 0 to any number such that the height of the pipe should be adjustable to our window height. So there's only a certain amount where you can have the pipe visible, and that has to be above sea level. So we're going to be generating like a random number between 0 and this number, like 0 and the width of your screen from height to just above the sea level. And then we're going to be subtracting it by 1.2 into offset, because there's a huge chance that we get like a pipe which covers the entire screen. So to prevent that, we're going to decrease the height of the pipes a little. And then after that, all we have to do is push our pipes into a dictionary along with their x-axis and y-axis coordinates. So this is basically what your pipe list is going to look like. It's going to be a dictionary which consists of an upper pipe and a lower pipe, and along with their coordinate values. So let's run this. Now this is basically the game loop that we're going to be using. This is going to call our various functions again and again until the game basically gets over, which is defined over here. So this function is going to run, or this is your basic game start. It's going to keep running until a certain condition is met, and let's see what that condition is. So over here, the different things that we're doing initially is that we're initializing our program using pygame.init. We're basically calling all the modules of the pygame library. Then after that, we're just setting the frames per second, displaying the title of the game on top of the game window, pygame.display.setCaption. So far we only have a pygame window, right? This is basically going to initialize the background images and everything onto this window. We're gonna start loading all of our different images into our game. So we have different images for the scores, the Flappy Bird image, sea level, background and pipe image, and we're going to convert it into a form suitable to display onto our window. This is basically done using the image.load.convert alpha function. So over here you're basically going to be loading your image and converting it into a form which is suitable to be displayed onto your screen. After that, we'll basically be doing a couple of basic startup things such as printing welcome to Flappy Bird game and press space or enter to start the game. And the second you see this, you know that this has started running properly. Now this is where you have the main game starting. So here you're basically going to be setting the position of the bird, and horizontally we're going to be setting it at 1/5 of the window width. You can basically set the bird wherever you want to. Then after that we're going to be adding the sea level, and over here we've initialized ground as 0. While true for event in pygame.event.get. Basically, while we keep getting a keystroke from the user, this whole loop is going to keep running. And what exactly is happening in this loop over here, basically we are running the program until the user stops or exits the game. Otherwise, we have basically created an infinite while loop over here. So if the event type is equal to quit, we're going to quit the game and exit the program. If the event type is key down, then we are going to be calling Flappy game. So this is basically us initializing the game start conditions. If the second after the game starts, the user clicks on quit, then we're going to quit the game and exit the program. Otherwise, if the user has pressed the key down, the space key or the key up, then we're going to be calling our Flappy game function. If the user hasn't pressed any key and nothing has happened, then we're just going to have a basic game display, and we're going to be displaying the background image, the Flappy Bird and the sea level onto our screen. This is just to keep refreshing the screen, and this is basically to set the frame rate of our screen. So let's run this. Now, if we look at our Flappy Bird game, you can see that we have all of the parameters initialized. We have a background, we have a sea level, and we have a bird over here. We've typed Flappy Bird game on top, and I'm going to press the enter key to start. So far as you can see, our pipes have appeared here. So we already know the function behind this. We keep getting our pipes, and the second that the bird crosses a pipe, the screen gets refreshed and our score gets updated. So if you notice here clearly, if I go slow enough, and if you notice, the second I did this, the display window actually got refreshed. And the second the pipe goes out of screen, as you can see, it gets erased and a new pipe enters. So the second this one pipe goes out, a new pipe gets created. Now, as we've talked about, there are three basic conditions. One is you hit the bottom pipe and the game ends. Another is you hit the top pipe anywhere and the game ends. And the next one is your bird falls below a certain level and the game ends. So these conditions are working so far. Our scoreboard also keeps getting initialized. Another condition that you might want to check for. Oh yeah, and as you can see, another thing that you notice is the velocity, right? So the bird is technically not moving. The bird's position relative to where it started from remains exactly the same. As you can see here, the only thing that is moving is its position on the y-axis. Apart from this, the pipes are moving. And do you remember the acceleration parameter that we have? This is where you can see it come into play. So I stopped, and the way the bird free falls, all of this is because of the acceleration parameter that we set. So this is basically how you can use Pygame to, create a game. Now let us quit the game. I pressed the escape key and the entire game has quit. So over here, system exit took place, as you can see. So this is all the logic that we've used behind creating a Flappy Bird game. And as you can see, we've used the Pygame module to create it.
And with that, we have come to an end of this full course tutorial. I hope it was informative and interesting. If you have any question about the topics covered in this video, feel free to put them in the comments section. Our team will help you solve your queries. Thank you for watching, keep coding, and stay tuned to SimpliCode.